All right, good afternoon, everyone. Welcome to the hydrology section. I'm not Clint Cromhout, but I will be your guest chair. I'm Casey Albrighten. We're ready for Ben Tobin to present his seasonality of flow paths and storm responses in a fluvio-karst system. So take it away.
Excellent, thank you. Thank you all for coming back from lunch. I'm going to talk about a project here that kind of started as a conversation that has kind of evolved into a bigger picture project that I'll touch on at the end here. First off, I think we've talked about dye tracing, and there's been some folks that have alluded to this, but it's a very dynamic system, right? So the hydrologic water level, if we think of it that way, is going to change over time as we see changing water levels, changing precipitation regimes, the heterogeneity of precipitation, all have the potential to impact how water is moving through the subsurface. And so with this project, we did a series of dye traces, but it started with the idea of river stage tomography. So with this concept, this model here, you have a river that's flowing through here. So if you get a flood pulse moving through this river, you can actually monitor that flood pulse, that wave, as it migrates away from that river through the subsurface, and you can see this wave propagate through monitoring wells and use that to really understand flow path dynamics in the subsurface. Well, as we were talking about this concept, we had in the back of our head that in Kentucky we have a conduit system that they actively tried to hit with wells, and as a result, we have a whole transect of wells here that ended up having some of them intersect that conduit, but others that did not. And so as we were having this conversation, we thought it might be valuable to put some data loggers in these adjacent wells, conduct a dye trace, and just see what happens to that dye pulse as it moves through the subsurface. So to zoom in on where we're talking about here, this is the lovely Commonwealth of Kentucky. All of the blue is the karst in the state. Something like 54, 55% of the state is karst. Mammoth Cave is right down here. It's our most famous cave system. The city of Bowling Green is also down here. We're actually going to focus on an area, wrong way. Over here, this is the inner bluegrass region, and so these are Ordovician limestones, mostly thinly bedded systems, but highly karstified. And within that, we are going to focus on the Cane Run Royal Spring Basin. So on the figure here, the outline in blue is the groundwater basin, and the red line here is the main conduit system. So this system has been studied since the 80s. John Thrakill and a bunch of others more recently, Jim Kearns, Randy Paler, Jimmy Fox have all done a lot of work on this system to really quantify the conduits within this system and the behavior of solutes and sediments as they move through. But most of that work has focused on the spring, some of the surface systems here, and the well that intersects the conduit. Not much work has been done to kind of connect these adjacent wells to the conduit. And so what we ended up doing here was two quantitative traces. So we injected dye into a sinkhole down here that entered the conduit, and this was known to flow to well number 20 right here. So we instrumented that well. We also instrumented two adjacent wells to the conduit that did not intersect the conduit directly. And then we conducted a dye trace in February and July of 2022. And more by luck than design, we ended up within 24 hours of the injection having a fairly decent storm event that provided us some additional information to really understand how these dyes are moving through the system. And just to kind of give you a visual on what we're talking about here, this is our line of wells. It extends further off into the distance here. The three that we're going to focus on here are well number 1, well number 20, which is right here next to the instrument house, and then well 18, which is a little bit further along here. And if we kind of superimpose roughly where that conduit is on this system, it goes right through that well 20 and 2 other adjacent wells that we're not going to talk about in this talk here, and completely misses all of the other wells that we're looking at in the system. So we have 2 that are adjacent, and the one that's in the conduit itself. And let's see. So yeah, what we did, this is our injection spot. It's a sinkhole that has a ephemeral stream that flows into it. This is during a flood event. So what we see here on the right is actually higher flow conditions in the winter, not during a flood event. And so from there, we will jump into our results here. And I'm going to split it out by trace. So we're going to have our winter results and our summer results, and then we'll kind of try to tie those back together at the end here. So first off, I'm going to look at the river, at the water level in the wells. So in this case, our dye was injected back over here. I've left that off just for simplicity here, but we did have this storm event, and we see all 3 wells, the conduit well here in blue and the other 2 adjacent wells, all have almost identical responses. So there was actually no delay in this storm pulse as it moved through the conduit and through the adjacent groundwater system. So that river stage tomography, looking at that pressure pulse, there's not much we can actually do with this as far as a delay in that, that water flow between these parts of the system. However, when we start looking at the dye, it gets a little more complicated. So what we ended up having happen here was our dye injection, and in the conduit, we had, at this higher flow, a very rapid response. So 2 hours, it was moving about 350 meters per hour using the straight line distance between the 2. It's a river, right? It's just a river that's moving through this part of the system. And then what we had after that, so we had our main pulse here, and then we had a storm event here. And just, I'm going to point out on here, and I'll kind of focus in on the next slide on this area, but these are on 2 different scales. So this scale over here is for the 2 adjacent wells, and it's an order of magnitude lower in dye concentration than what we are actually seeing in the main conduit well. And so when we zoom in on this, we see that there is a little bit more complex of a response. This is pretty well correlated with that storm pulse. So we actually see water from this storm event pushing water out of storage into both the main conduit and the 2 adjacent wells. So this is really exciting. We hadn't done this before. It was great to see that there was this connectivity between the matrix or the fracture porosity and the conduit that had a very rapid response. So we were excited about that. We wanted to see what happened in the summer. We came back. There's a lot more vegetation there in the summer. This is pretty much the same angle as the last photo, but the plants take up everything. So in this case, we had generally overall much lower water levels. So the conduit well, the conduit is about 100 feet below the surface here. The water level dropped 15 feet between summer, or sorry, it was 15 feet higher in the winter as compared to the summer. And so we had, again, a very similar setup. We had our dye injection occur over here. And in this case, we were actually able to install a data logger at Royal Spring, which is the downstream outlet of the system. And it also happens to be the water supply for the city of Georgetown, Kentucky. And so we saw with all of these, again, our 3 wells all had similar responses and timing of that response to the precipitation event here. Royal Spring is a little bit more complicated, but we do see a similar response there with the water level. And so when we go to the dye injection, or to the dye trace results, it was fascinating because there was no dye detected in either of the adjacent wells. However, we had a very distinct double peak in the main conduit. So we have our dye injected here, a large recovery peak just as we would expect, and then after the storm event happened, we actually had a higher spike in that dye concentration, which suggested that there may have been some storage within the system that we weren't thinking about. And then the other part here is that initial travel time was much slower. So in the winter, it was about 2 hours to that well. In the summer, it was about 14. And then getting down to the spring itself, it was about 82 hours, going at a much slower rate of speed compared to the winter trace. So thinking about this kind of more holistically, comparing both the summer and winter, all three wells responded hydrologically the same. The water levels all responded at the same rate very quickly after our storm event. But in that summer trace, we didn't actually see the dye show up in those adjacent wells. We also saw that double peak, which suggested that that storm event was flushing water or flushing dye out of kind of a shallow storage there. Let's see. Maybe now. Uh-oh. All right, yeah, can we go back a couple? Sorry about that. Excellent. Well, so while we're figuring this out, it's kind of been an interesting thing to think about this as far as where that dye may be stored. So we are injecting directly into a sinkhole that is theoretically tied, or is shown to be tied directly to the main conduit. And one of the thoughts that I've had with this is that there is actually some storage within that, the sinkhole within that unsaturated zone as the water's going in, and these storm pulses are large enough to actually move some of that sediment, or sorry, some of that dye further into the system that had gotten hung up. Sure, that works. And so let's see. The big thing that I wanted to kind of hit on with this is this is just one set of data that we're using within this project. So this is an NSF-funded project on data fusion in karst systems. And so what we're doing is with this project is trying to incorporate all of the data that we collect for groundwater systems, from the geophysical to some well tests to the tracer data, and utilizing all of those data sets in combination to really understand the fracture patterns and flow behavior within the fracture system of this karst aquifer. And I guess with that, the one thing that I think I need to acknowledge are our collaborators on this, Dr. Jim Ye at University of Arizona and Dr. Kruger at the University of Iowa, who are collaborating with us on the rest of that data. And with that, looks like I have plenty of time for questions.
how much the total amount of tracer that you recovered? Was it complete, or is there still storage in the system?
So with the double peak, we end up getting the majority of the tracer. I don't remember exactly what the calculation was now, but I think it was on the order of 75 to 80%.
Cool stuff. Just a technical question. The stage measurements, those barometrically corrected, so they're actual
They are.
water level measurements? Thanks.
Oh, thanks, Ben. All right, next up. Next up, we have Bartolomé Andreo and his talk on vertical shaft monitoring to assess mixing processes in karst aquifers.
Yeah, thank you. Well, I will present you some results of a project we are doing in South Spain in connection with the karst pilot site, where there are different processes. We are applying different methods in order to investigate how function this karst system. Well, yeah. Now it seems okay. So our aim was to investigate how function this karst system in South Spain using different techniques, but mainly hydrodynamic and dye transfer techniques. This is a project supported by European Union and National Agency for Research, and this is in the framework of the first author, Beatriz de la Torre. And don't like to work, it's afternoon. Yeah. Now, so this is the scope of the presentation. First, I will introduce you the pilot sites and the objective of this communication, and then the method that we have used in this case, and then analysis of the results, a little bit on discussion, to finish with some concluding remarks. Well, most of us know that really karst aquifer is an environment, a natural environment that responds to the rainfall infiltration through the soil and epikarst. Now I hear more the name of critical zone, and then progressively is going down, and then the water flow through the saturated zone to the karst spring. The whole of the system function transform the entrance of the rainfall into the output, so we can record at the karst spring the different response, both hydrodynamic, flow rate, hydrochemical, isotopes, and of course hydrothermal as natural response, but also artificial or dye transfers can be done. Anyway, if we use many of these tools, then we will make a more robust model, conceptual model, how function our karst aquifer, analyzing the different response in order to deduce the aquifer behavior. So the objective of this presentation are really first to characterize the aquifer behavior in this area. We will focus in your karst spring that is only functioning during some period. It's really an overflow spring located in a very complex area from geological standpoint. And then we will try to define how mixing process occur after the infiltration of rainwater through the karst system. Well, in Europe, around 1/3 of the land surface is karst, mostly limestone and dolostone, but also evaporite rocks. And in Spain, about 1/4 part of the territory is really karst, predominantly, thank you. Predominantly, I mean to say limestone and dolostone, but also they are evaporative rocks. Our pilot site is in this area, just close to the coastal, Mediterranean coastal area of Andalusia in the south. And this is in more detailed scale, the geological map of this area. It's an area geologically complex because there are two major units in that area. On one hand, at the north of this overthrusting contact is the external zone of the bedic range. This is a continental paleomargin during the Mesozoic age. And at the south, there is a mainly metamorphic, but also sedimentary rocks that are overthrusting over the external zone through this orange color that are flysch deposits, clay and sandstone mainly, molassa deposits. So we have Jurassic series at the north and Triassic one at the south. And they are separated by this clay and sandstone in orange color located in between. So at the north, we have at the bottom clays and gypsum of Kuiper Triassic. Over there, dolostone and limestone of Jurassic age, and finally marly and marly deposits of Cretaceous age. And at the south, we have dolostone of Triassic age, and these flysch deposits are really tertiary general. So I will show you some geological cross-section just to show the geological structure in this area. You can see the anticlinal structure at the north, the Triassic clay, sulfates and clay, and then the dolostone and the limestone, Jurassic, the Cretaceous rock, and then the tertiary clay and sandstone of the flysch age, and then the Triassic dolostone of the internal zone. So tectonically it's complex, the area, but the structure is similar at different places. You can see more or less the same structure. So they are the main spring located at the south of this contact. You can see some of them at that point. Normally they are the spring located at lower altitude, but high mineralization and temperature, and really a small variation, all the chemical and hydrodynamic characteristic. Then, more in detail, you can see here the Pozancón and Alfaguara spring that are located northward of this other spring, so-called water spring. Alfaguara is an Arabic name that means karst spring. This means a really rapid variation in flow rate. This means Alfaguara. And Pozancon is like a big well, obviously a natural well. So you can see how at that point the geological cross-section saw always the same limb of the antiform structure dipping toward the south, and the permanent spring, very small flow rate, and the overflow spring of Alfaguara and Pozancon. This is the hydrogeological framework, and just now some slide to see karst feature, karst landscape at that area. This is the typical Mediterranean karst. It's quite similar to classical karst in Slovenia. Here there is no really runoff. Water, rainfall water infiltrate into the karst limestone. You can see dolline and some current and also sinkhole. I don't know if I am using correctly the name of sinkhole and dolline after presentation of Professor Irasasovsky. But anyway, and also many other pictures at that point. Yeah, current field here and sinkhole, many of them, small caves at that place. Also travertine deposit connection with the waterfall and that case. Well, this is a hydrological sketch. You can see this is location, the location in the area. This is the shaft in low water condition, and this is in the very high water condition. And this is one sketch. You can see how water table is in low water, normally around 643 meters above sea level. And then the first overflow spring, Alfaguara overflow, is 658 meters, and just 6 meters above is the higher one, Pozancon overflow. So we have two overflows from spring over this water table, this permanent water table. And yeah, you can see also the monitoring point in that area. In that area are the small springs located just close to this contact. So they are really a small spring. They are permanent, but they are a small flow rate, and this is just one example of this type of spring. The flow rate is between 60 and 80 liters per sec, so this is really relatively low flow rate. And there are certainly variation in the electrical conductivity because of the sulfates and calcium that have relatively high concentration because of the gypsum at the bottom of the aquifer. And then it's possible also to see how the total organic carbon varies a little bit, but not like in the overflow spring as we can see later. So this is a record of the spring located southward of the study area. And this is a picture of the overflow spring, just draining water in high water condition. It's really a valley. Normally it's dry, there is no water. However, in very high condition, you can see till around 20 cubic meter, so 20,000 liters per sec. So really it's a beautiful place just for a few days, no more. but people is going there to visit this area, this geogeable area. This is just at the south of a small village, and during these days, the village is really the core of the attraction because of the spring. So we monitor in that area first the in surface, in the high part of the mountain, we install a meteorological station, but also we monitor water in the soil and water of the rainfall for chemical and isotopic composition. And in the spring, in the overflow spring, just here, we have a continual records of electrical conductivity, temperature, and water level. Then we collect sample for each spring, both permanent and overflow spring. Obviously, in low water condition, it's possible enter into the aquifer and collect the sample directly in the saturated zone. However, in high water condition, only outside of the aquifer we collect the sample. And then we analyze this sample for chemical isotopic data, and also analyze this result, also the hydrodynamic ones from a different standpoint that I will show you later. This is the record for the overflow spring, so-called Pothancon spring. You can see here is the record of the water level, and this is just when the spring is overflowing, so very, very short period. The most of the data are coming directly from the saturated zone of the aquifer within the shaft where the water flow emerge. So we can see how during high water condition, in general, we have an increase in electrical conductivity and temperature because of the major ions, particularly hydrocarbonate and calcium, are progressively increasing. However, the response is a little bit more complex. I will show you later, but in general, we can see how, for example, total organic carbon increase coinciding with this peak of flow rate. So this means that really at the spring is arriving water recently infiltrated coming from the soil. So we study with a little bit more in detail the record, the hydrodynamic record. We can see the rapid answer for each input of rainfall, but only some of this input produce effective discharge by the overflow spring. So we have different measurement of flow rate in function of the altitude, so we can deduce the flow rate, and certainly, as I said before, they are increased in the water table and overflow condition, and the electrical conductivity show dilution. So dilution peak within a context of increase, dilution peak coinciding with the peak of water table. And at the same time, we have diminution of temperature. So it seems that during high water condition, as general response, there is an increase in temperature and electrical conductivity. So this means like a piston flow into the system. And then punctually, we have a small punctual dilution and diminution of temperature coincided with the peak of water table. So then the situation become contrary during the depletion curve. We can see the increase in the electrical conductivity and in the temperature. Here it's possible to see how the water table variation are really very rapid, as expected in a karstified system like this area. So when we analyze the flow rate using different techniques, spring hydrograph, correlatory analysis, or wavelength analysis, well, we always obtain similar results. The rainfall is a random effect, quickly decrease the autocorrelation function, but the water table, this is the total response, is more or less similar. Also depend of the hydrological years, if this is a more dry or humid condition. In the dry condition, the response of the system is a little bit more inertial, because the water, the rainfall water, infiltrate, saturate the soil and then saturate the sun, and then is when the system really responds through the karst system. Yeah, like this, we can analyze more in detail the flow rate, for example, using cumulative relative frequency. It's possible to see how in 80% of the cases, the flow rate is, or the water table is under 645 meters. And then only 20% of the data are above this water table. And we can identify different, in this scale of probability, different period hydrodynamically. So it's possible to identify the low water condition and how the water level is progressively going up during the piston flow and the decay situation, and then in the overflow spring, how this water table is really in the top. So these images are representative of the depletion situation when the water table is accessible within the cavity. Then when the water table go progressively up, provoking piston flow from, as we can deduce from physicochemical parameters. So the period that both karst springs are overflowing, and finally again go down during the declining period. So hydrodynamically, it's possible to identify this period, also chemically, but I just will show this picture comparing total organic carbon, but particularly 13 carbon. It's very clear, very visible how the water of the piston flow condition are really the less the deplete values of 13 carbon. So water is storage in the saturated zone for longer residency time, more in contact with the rock, and consequently less depleted value. However, in that area are located different samples corresponding to the outflow or the overflow period, and also to the moment in which it's overpass the peak of the hydrograph. So we can distinguish the different periods also from a chemical and isotopic standpoint. And this information we have from natural response, hydrodynamic temperature, and also isotopic data and chemical ones are very well in connection with dye transfer we have done in this area at different place in the catchment area of this karst spring, and we have done around 7 dye transfer tests at different places, and most of them show result coherent with the response we have deduced from hydrodynamic and hydrochemical standpoint. And yeah, this is the picture. You can see most of the tests demonstrate the connection with these overflow springs. So the geological structure and the are really condition the flow path toward this karst spring, and yeah, most of them are really in connection with day. So we have many breakthrough curves. You can see here just some of them. Obviously, the result depend of the hydrodynamic condition, and also depend on where the injection has been done. But at least we can do a conceptual model how function this aquifer, like several karst conduits, major conduits, connect with the most important one, that is supplying both Ancon and Alfaguara karst spring. The travel time we deduce from these dye transfers vary between 15 and 60 hours approximately, and the velocity are always around 100 or more meters per hour. So it's a really karst area, and I can say this is not relatively common in South Spain to have this type of velocity in karst. Normally are lower than this. The recovery rate of the transfer mass inject varies between the 14 and 72%. So they are different transfer recovery. Conceptually, we think that the system functions like this picture. So they are. This is the recharge area of the catchment area of the spring. They are permanent spring in that area at the south, like Huerto, La Tua. So they are spring located at lower altitude with low discharge, but high mineralization and temperature. And this is because the sulfates and the residency time is longer at that point. And then they are, during the very high water condition, they are two overflow spring draining, more recent infiltrate water. Also, at the beginning of each recharge period, exists piston flow exists. So the water do like this, more mineralized is going to the overflow. But then when the rainfall infiltrates, this dilute water is also there during the peak of the discharge. So it's more or less the result we like to show. So the analysis of the hydrodynamic response in this karst aquifer permit to deduce different hydrodynamic conditions for the same spring. So the chemical and isotopic data are congruent and permit to identify better this hydrodynamic period. So the combination of hydrodynamic and hydrochemic information, it permits to infer how function the karst aquifer. So we can identify periods in which is, piston flow exists, or when really start the outflowing period with water coming from recent infiltration till the peak of the spread hydrograph pass, and then start the decay and then the depletion curve. And this is coherent with information coming from the digrapher, which means that if we really combine the different sponsors, both natural and digrapher, interpretation become much more robust. Normally, if we use just one, then we will have more in 32. For example, if we use hydrodynamic data, we will now increase of flow rate, but we don't know where it comes from the water at that point. Yeah, this type of result illustrates clearly how interesting it is really use different tools to not only know the aquifer behavior, but also to protect and to manage water, which is a crucial topic, at least in the Mediterranean area. So, yeah, it's just my final slide to thank you for attention. And this is the 3 recent papers in the area, 2 in Journal of Hydrology and 1 in Hydrological Processes, just to ask complementary information in case you need. And I'm available for questions. Thank you.
Oh, thank you, Bartolomé. It looks like we have time for one question, maybe.
Very, very fascinating site there, Bartolomé. I have a question just about getting back to one of the slides where you showed numerous analyses have been done. I was trying to count them and seeing how many different analyses and how many times you sampled. I was just wondering what is involved and how many actual samples were collected to get that set of data.
How many samples?
Yes, how many over that period of time, and what was that period of time?
This one.
No, it was earlier. There's numerous charts. Yeah, there was, good 20 or more. Let's see, there, that one. So yeah, I was just looking at that and kind of overwhelmed by the number of analyses and how many data points are on there. So are those, how many of those can you do continuous data, and how many do you need to have analyses sent to a lab? And yeah.
Yeah, well, this is a record for 3 years approximately. But we combine here a different type of record. On one hand, continuous records, and that case for the water table, but also for the electrical conductivity and temperature. And in this case, we have 2 records. One is the continuous record, is the continuous line, but also single measurement. So each time we go there, we take measurement, take data of each one at the same time, one sample. So you can see how the data collect just every place, every day we go there is exactly coincident with the continuous record. So normally this means we are really right, and it's a good manner to sample. Obviously, this means a lot of work. A lot of days go there to collect this quantity of sample. For Beatriz de la Torre PhD thesis, she collect around 1,500 samples to analyze mainly major components, but also not for all, but just for the most interesting crops and the other components. So it's a very hard work to collect sample like this. Yeah, but it's really the only manner to really understand what is occurring in the karst system. Because the karst systems are really particular from hydrodynamic standpoint, so we can collect samples, for example, every week or every month, but then we will not really interpret what is occurring within the system. So we need, at the beginning at least, for 1 or 2 years, collect samples, the maximum number possible, with the behavior of the aquifer.
Well, thank you for that. I know it just seemed like you must have either a very large budget or you make a lot of use of cheap student labor.
Yeah, thank you.
Oh, thanks again, Bartolomé. Next up, we have John Barry with comparing and contrasting standard dye tracing monitoring techniques.
I'm going to try to do a quick battery change in this to see if I can mitigate some of that static. Hopefully you get some better audio. Thank you.
Okay, thank you. So I'm John Barry. I work for the Minnesota Department of Natural Resources, and I'm a hydrologist in our county groundwater atlas group. So the group studies counties typically at a large scale to look at aquifer pollution sensitivity, but we also do groundwater mapping in smaller scales. So we do a fair amount of groundwater tracing in southeastern Minnesota. This work was done in conjunction with a few collaborators, Peter Kang and Calvin Alexander of the University of Minnesota Earth Environmental Science Department, and another collaborator, Martin Larsen, who works for Olmsted SWCD. So Minnesota is located in the upper Midwest, up near the Canadian border, and when you zoom into Minnesota proper, the southeastern portion of the state is covered by karst. So it's a karst terrain, karst flow, turbulent flow in the aquifers, and a fair amount of caves, sinkholes, dissolution features. And Olmsted County in particular, where we did the tracing that I'm going to talk about, is primarily dominated by Ordovician and Devonian carbonate. So pretty much everything that's, oops, all right, I'm doing it too. Here we go. So everything in this kind of lighter green, the darker blues, the purple, but also these lighter blues, that's all Ordovician or Devonian carbonate. So there's a lot of carbonate in Olmsted County. And if you look at the stratigraphy and hydrostratigraphy of the Galena group, which is where we did this work, there's a lot of preferential development of sinkholes and sinking streams and springs. So very specific hydrostratigraphic intervals will have common preferential development there. And in the county just to the south of Olmsted, which is Fillmore County, there are large cave systems. So there's commercial caves as well as a number of caves owned by the Minnesota Cave Preserve. So what we're talking about are really rapid groundwater flows through well-developed karst, so kilometers per day. So the Bear Spring Springshed, which is where we did this work in 2022, is definitely a karst area. It's located in Olmsted County. We've got a lot of sinkholes within the current delineated Springshed. So right now we're at about 80, and that number, of course, is always changing. They get infilled by farmers. They develop each year. But we're looking at a large number with the varying size and shape and depth. But also in this same neighborhood, so to speak, about 4 kilometers to the southwest, in 2020 aerial imagery from Maxar, we were able to look at crop lines. So it was a drought year and the crop line showed up using that same technique that Sam Pano did back in 2013. So looking at this field, and then you can kind of delineate them, and sure enough, there are 3 dominant fracture trace trends. So again, we're in a very karstic terrain. And then lastly, Martin, who is one of the collaborators on this project, is also a very avid caver. And just about 6 months ago, he pushed the overflow spring. So most of the data that we present today is either coming out at Bear Spring or was collected at Bear Spring, but there is an overflow spring. And Martin and a fellow caver, Emily Hudson, pushed that overflow spring and mapped about 610 feet of cave. So just letting us dig in further that we are in a super karsty area. So Bear Spring is at the contact of the Prosser and Cummingsville, so that's a very common hydrostratic interval for springs. And the main reason we're doing this work here is because we have an accessible location, we have willing landowners, and the same year we started this project, we were able to instrument a well nest about 1.5 miles or so to the southwest, and then it's a perennial flow spring. So here's the site, and there's that overflow spring when it's activating. So we get increases in order of magnitude or more after a large recharge event. And starting in 2017, we instrumented it with level and temperature, talked the Minnesota Pollution Control Agency the next year into coming out and putting in continuous nitrate for us. And since then, we've been doing anion grab sampling and geochemical suites and doing some specific pesticide collection too for neonicotinoids. They came on the market in the 1990s, so if you detect their presence, you kind of have a residence time indicator with them in your spring. And we've been getting some pretty sweet data. So this is older data, but it was just easy to dump into a PowerPoint. And you can see after large recharge events, there's these instantaneous increases in discharge, which is in this blue. We get temperature increases in the summertime or decreases in the winter. The nearby monitoring well in the same well group, the Galena, has very similar rises. They peak similarly. And the nitrate behavior has been very interesting, and we're all still looking into that. But depending on when the rain comes, we often see this instantaneous dilution, from dilutions that solution. But after that, we get mobilization in nitrate in the soil column and in the epikarst. So we often have these stepping increases after precipitation events. So all this is letting you all know that this is a very karsty neighborhood where we're doing a lot of work. And because of that work, we were able to leverage kind of what we've been doing to ask for a grant from the Minnesota Department of Health. And they gave us another $50K to basically do more work in this neighborhood, and that's what we're going to present today. So as part of the $50K they gave us funds to buy an AV probe, and that's going to help us determine the upper flow for our rating curve development. It's really hard to get down there and get the upper flows before you're on that recession curve. But in addition to that, it's giving us funding for cropping system tracking. So that's Martin going out and talking to the farmers, see what was planted within the spring shed during these time periods. And then in addition to that, lysimeter installation, and then a budget to run anions at the lysimeters. But lastly, they gave us some budget for additional dye tracing. So and in particular, they gave us budget to buy in situ Turner design sensors. So we were able to buy a uranine, rhodamine, and an eosine sensor and data loggers to do this work, and as well help pay for some of our time. So in 2020, we planned these traces. We went out, we collected background levels to figure out which dyes we could use. We determined some targets, and we went out to do this work to see if we could better delineate the spring shed itself, and also see if we could, kind of tease out some of the aquifer characteristics with these data. And so this really gave us an opportunity to do high intensity monitoring using some of our standard approaches. So typically in Minnesota, we use passive sampling, which are carbon detectors, and we pretty much always use those. And historically, we've done water grab sampling using automatic samplers, so like ISCO samplers set up, so that could give you high resolution breakthrough curves. And here it gave us the opportunity to do all those things. So the groundwater spring watershed at Bear Spring, as identified through 2015 and 2018 traces, was basically this here, this kind of grayish blue. And in 2020, we took a lot of that data that I was showing you, the discharge data and the recharge data, and we did basically some watershed analysis. We knew what was falling on the spring shed. We knew what was coming out at the spring, and then we used some watershed yield numbers, basically curve numbers, to figure out kind of a maximum and a minimum spring shed size. And so what you're looking at here are kind of minimum size based on that watershed calculation and our maximum size based on that calculation. And one thing I'll point out is that we really, and so these are really drawn, of course, using your inferred groundwater flow directions, but then you have some kind of artistic license in terms of where you think those boundaries should be. Should they go to the east or to the south? And you use potentiometrics to kind of help guide that decision. But here we also use chemistry to help guide that decision. So Bear Springs usually around 30 parts per million chloride. Springs that are flowing in a different direction, like off to the southwest, are around half that. So we were, oops, did it again here. Let's see here. Oh, going the wrong way, sorry. So we were assuming that the chloride loading was very likely coming from Interstate 90. Minnesota is a very cold state where we get a lot of cold weather and snow, and so there's a lot of halite application. Oh gosh. A lot of halite application along Interstate 90 here. So with that said, we had 3 targets. We chose our dye masses and we poured some dyes. So we were lucky enough to find all 3 of our dyes. So the targets are shown here. They're basically the sinkholes that are shown as bold X's and that have labels. And in particular, the one that got us the most excited was this one here, this 55D 1574, which is just this unique number that we use in a database system in Minnesota. And sure enough, that pushed the boundary kind of to where we were speculating that it would go. So now we assume that we are getting some of that chloride loading from that I-90. So getting into the intensive monitoring. We use the passive carbon samplers, so that's activated charcoal in permeable socks that you put out before the trace to figure whether there's any fluorescent dyes in the water, and then you can change those periodically through an investigation. And your basically your temporal resolution is really limited to how often you change these, right? So next to that, we put in these ISCO auto samplers. So we had 4 of them connected to solar panels, deep cycle marine batteries, and we set them for 15 minutes for the first 48 hours of the trace, and then hourly after that. And then here are our new field fluorometers. We set these to 1-minute intervals, and I will point out maybe 2 things here. The ISCO auto samplers were basically collecting from the same location as our Turner sensors, and then secondly, they were basically, here are your ISCO samplers and the tubing, so they were located right here. And that's within the channel of the perennial spring run. And that became a little bit of an issue. So just a quick primer, the passive carbon samplers as well as the direct water samples were run through Calvin and Peter Kang's lab at the University of Minnesota. And basically they either run them directly or they use an eluent to kick the dyes off. But in essence, the dyes have very characteristic peak wavelengths. So you can determine whether you're looking at a fluorescein or an eosine or a rhodamine or a sulfur rhodamine bead, rhodamine WT, et cetera. But the laboratory instrumentation as well as our in situ field fluorometers are affected by something called signal quenching. So as dye concentrations increase, your dye concentration increases, your fluorometer reading will only increase until a certain kind of nick point. And then after that, your signal is attenuated and quenched. And at really high concentrations, it'll actually decrease. So both our direct water samples and our in situ fluorometers are affected by that at high concentrations. But the biggest difference between the 2 approaches is if you have direct water samples, they can be diluted in the lab using wet methods. So you could, dilute it by 2, and then you would know you would have double that concentration. So above the linear range, we can estimate dye concentrations using the laboratory samples. At high concentrations using these in situ fluorometers, we can't. They basically peaked out. Getting to the kind of the results here. So what you're looking at in this table is our background monitoring, looking to see what was kind of in the neighborhood before we did our dye inputs. And then starting on the 25th, we introduced both our fluorescein and rhodamine, and then we didn't introduce eosine until the next week due to some logistical reasons. But the bugs were very consistent with what we found, and more importantly, they were very consistent with what we'll get into on the next couple slides here. As I mentioned, the passive carbon samplers are the most commonly used method. They're really a dependable method, and they're also a low-cost method. You're not running a lot out to change auto samplers or running hundreds of samples, from your carousels, and they provide us with really good inferred groundwater flow directions for spring shed delineation. Let's see, just another point, these are integrating collectors. So they are kind of semi-quantitative. One bug may have a little bit of dye in it, the next week it'll have a lot, and that'll let us know whether that pulse is coming through. But it really only gives us an envelope of time. We can say that dye broke through, between this date and this date when they were changed. So that'll give you a minimum and maximum flow rate, within that envelope of time. And the main point is that the bugs were very consistent with our other methods. So getting to the next two methods, the direct water samples, which on the next graphs will be called Shimadzu, because those were run through a Shimadzu spectrophotometer, and then our in situ results, which on the graph will be labeled as Turner. So here we'll be comparing 15-minute data from the direct water samples to the 1-minute data from the Turner sensors. And here's really what it comes down to. Both of them, so our dye input was here at 1434, and after that our dyes arrived in the direct water samples and in the in situ fluorometers with very good resolution. However, do note that this is normalized in situ data. So the concentrations in our Turner values were 2.41 times lower than what we were calculating through the direct water samples. So the the first arrival of our dye arrived at 1805, so that was within that 15-minute window for those direct water samples. The peak arrival was a good fit as well. It arrived at 1831, and that was within that 1830 to 1845 interval. So that was great, and then you can also see that the behavior was very the same. Initial peak, we had this kind of secondary and then tertiary peaks. So you can notice that after a certain concentration, though, these diverge. And so the main issue there is that if you're really trying to if you're trying to estimate the extent of your tailing, the in situ approach didn't seem to underestimate it, and that can be really important if you're trying to figure out late time tailing. One other thing about this trace, we poured the dyes basically, here's your input time, and you notice right before this trace happened, we got a fair amount of rain. And so the area was primed, so to speak. We got our dyes in the ground, and then we got rain the night after pouring the dye and the next, actually in 2 different pulses that night. So that's what we're looking at here in terms of the secondary and tertiary peak is kind of remobilization is how we're interpreting that of the dye from water moving across the fields into those sinkholes. Those were the peaks at 8 and 12 hours. Another thing to note is that the sulfur-rhodamine B concentrations are roughly 2 orders of magnitude less than fluorescein. So fluorescein is roughly about 10 times more fluorescent than sulfur-rhodamine B. But sulfur-rhodamine B is more likely to adhere to soil particles. And the location where we poured the dye had a nice open throat when we first started, but then the walls sloughed in and plugged. So we feel like we probably lost some of our dye to soils within the sinkhole itself. And then comparing the rhodamine to the direct water samples, for at least the initial arrival, there is some discrepancy. So the initial arrival using the in situ was at 1807, yet the auto sampler caught it sometime in that previous 15-minute window. And we think that's attributed really to just kind of the poor resolution at low concentrations using that probe. But by the time you get to your peak arrival, it fits well within that 15-minute time increment. And again, this is just for this brand. This isn't being. We're not thinking that all sensors would behave the same. So another thing that we found doing this high resolution test is that the field fluorometers have really wide wavelengths. So if we bring samples to Calvin's lab and run it in a Shimadzu, I don't know what the wavelength is, like 30 nanometers or something. It's looking at 5 nanometers. So it's looking at a very, very narrow bandwidth. And these Turner sensors have really wide bandwidth. So that's one of the things we determined is that in this trace, the rhodamine sensor actually picked up the uranine dye as well, but the uranine sensor did not pick up the rhodamine dye, so that we do have a little bit of crosstalk between these specific sensors. And then lastly, I was out there for multiple days in a row just to decant auto samplers, make sure batteries were working, and all that. And so, after the pour, I was there actually when the dye came through. So I had a hint that there was some green in the water, but I was busy working on batteries and things up here. And by the time it occurred to me to finally take a picture, it was fairly high, but this was still about 16 minutes ahead of the peak arrival. So the next, someone may want to ask, what sort of mass recovery did we have? And that's why I brought this up earlier. We bought this equipment, between the 3 of these sensors, that was about 16K, and then all these auto samplers, and I'm standing on the road taking this picture. And so we got the equipment as far away from the road as we could to limit, vandalism or theft, some things along those lines. But I'm actually going to purposely go back now. The spring's discharge was climbing the whole time we were there, and so we ended up the overflow spring, or basically we got flux coming out of that, and in that happening, some of the dye actually came around out of that overflow spring and came down and missed where our sensors were. So. You're always disappointed with something in field work, and that was one of the big disappointments here. So, in summary, we found really good agreement between each of these most commonly used techniques. And I guess I will step back a little bit. There's lots of great references. I found multiple, and since we started this work, people have shared others with me. But I couldn't find any references where all these approaches were compared for the exact same trace. So the summary is that we found really good agreement, that the data resolution varied in concentration and temporally, but it was quite good, that the flow-through in situ fluorometers capture the overall shape and breakthrough very well, and that direct water samples were better at that lower end and the higher end. And so the goals of a trace really should dictate what you're going to do with the trace. So, if you're looking for just inferred directions, then you could use bugs. If you want breakthrough, and that's all you care about, you might want to consider an in situ fluorometer. Or if you really need to determine late time tailing, well, then you might want to have direct water, high collection temporal samples. So we're going to repeat this work again in the next couple months here. And yeah, thank you. Any questions?
Thank you, John. Yeah, we're up against the break and got time for questions.
I don't know what that means. Maybe it's a good thing. Maybe people are hungry.
All right, thank you, John.
All right, thank you.
All right, welcome back from break, everybody. We're getting ready to go ahead and start the second half of the hydrology session. John Barry back to the stage. And he's going to be telling us about identifying recharge and flow in fractured crystalline rock using karst characterization methods.
Thanks. Okay, so sorry that you have to have the same presenter 2 in a row. This was the work that we had initially thought we would be submitting, but we had a deliverable deadline for the work that I just presented, so that's how we ended up with 2 here today. So yeah, this is a talk about using karst characterization methods in the northeastern portion of Minnesota, which is a non-karst area. So this work is done by myself and Jim Walsh at the Department of Health, Tony Runkel at the Minnesota Geological Survey, and then I snuck in some data from Tom Aley from Ozark Underground Laboratories as well. So just a quick setting the stage from a geologic and hydrogeologic perspective. Minnesota has very complex geology. It's a pretty big state, and you can kind of distill it into more digestible content by creating these groundwater provinces. So the DNR has created these 6 different groundwater provinces, and I'm not going to read them all to you. But in essence, the karst is the area that we just talked about in the last talk, and that many of you are very familiar with, and then the arrowhead. And so in some ways, they're very similar provinces. I think aesthetically, they're both the prettiest provinces in Minnesota. You're either overlooking Lake Superior with beautiful vistas, or you're overlooking the Minnesota River Valley. But the geology is very different. You know, carbonates in the karst, and up north it's exposed and very shallow crystalline rock. So very limited aquifers with a lot of yield. So the karst province, there's a lot of available information. So very high resolution mapping through the Minnesota Geological Survey, a lot of Devonian and Ordovician carbonates. We've got a karst feature inventory that Calvin Alexander and others started many decades ago. The DNR now is serving it. We have the Minnesota Springs inventory that Calvin and others started as well, that the DNR is serving right now. Oh boy. Maybe you can, yeah, current, thank you. And then we also have the Minnesota Groundwater Tracing Database. And so the database, if I zoom into this section of Fillmore County, you can see that we've got, you know, hundreds and hundreds. I think we're over 700 individual traces now, and we're delineating some pretty large spring sheds there. So all this information is actually, I'm going to do a shameless plug real quickly. All that information that I just showed you for the karst area of the state is available on the Minnesota DNR Spring Shed and Karst page. So if you Google that, you can get the web applications for any of that data. But then there are also just decades and decades of research. So work by Calvin and others, state agencies, a lot of theses, et cetera. So there's a ton of work in the southeast. Then you move up to the Arrowhead, and so we know that there's not a whole lot of aquifers available up there. We do have some good mapping. This is kind of aggregated mapping, but you're looking at crystalline rock, really old Archean rock, kind of towards Ely in St. Lawrence County, or Paleoproterozoic and Mesoproterozoic rocks near Lake Superior. And there's some surficial deposits on top of that. So the areas in brown are basically unconsolidated, typically sandier, superior lobe deposits. And in that area, there's also the Boundary Waters Canoe area right up against the Canadian border. So there's a lot of that area is just undeveloped and is going to stay that way. So the dots on this map are wells from the County Well Index, a database in the state of Minnesota of well locations and depths. And you can see there's about 45,000 wells or so in the Arrowhead province. And if you look at the red ones, there's about 15,000 of those. And those are all wells that are related to mining exploration. And the take home there is that roughly a third of the wells in that neighborhood are mining wells. But that also means that most of that data is not really available in terms of what they determined with that. So there's a lot of geologic and groundwater characterization in that neighborhood, but a lot of it's kind of provincial and not released to the public. So we started working with the Department of Health to help them do some work at a site near Ely, Minnesota. And it's a camp on a big lake up there. There's bedrock outcrop that's abundant. It's basically a schist and wacky protolith. And the limited understanding of groundwater at the site was basically that flow is to the southeast. So we came up with different approaches that we were going to do to help them. And so part of it was dye tracing their wastewater lines. So we did some of that. So they've got on-site septic systems. The Geological Survey helped the MDH with a number of borehole investigations. We did a fair amount of groundwater chemistry, so that includes a number of wells at the site, lakes in the neighborhood, and then all this is precip data from the Hibbing weather station that the DNR runs. And so we utilized that data. And then we also collected a fair amount of continuous data. So we deployed continuous conductivity sensors, and then we also collected some time series stable isotopes. And then lastly, Jim at the MDH had a separate contract with the USGS for microbial sampling at several of the wells at the project site. And the microbial sampling basically ran well water through these like kidney dialysis filters, and then they were sent to a lab in Wisconsin that could tell you all about the microbes that were present. I honestly don't know a whole lot about that. So the results at the Ely site. So we had 3 wells that we were really interested in, well 7, well 2, and well 3. And our first pour of dye was basically the picture that I showed, someone pouring dye in the urinal was here. We later went back and poured dye in a floor drain at this location, and we also put dye in a outdoor privy at this location. And we have found dye at well 7. We also found very rapid weeping from the septic mound into the surface waters. So eosin was detected at well 7. Unfortunately, this site has 11 wells across the entire site. We were just focused on these 3, but they are very low yield wells. So each of these residential buildings have piping from each of the wells, and that way if one well goes dry, they can manifold it over and still deliver water to the sites. And what that meant was that we detected dye in that well, but we have a very poor handle on the time of travel because those wells are getting manifolded differently through the project. And to date, we've got no detection of sulfur rhodamine B or the uranine. But we do plan on changing those bugs a couple more times before the June 30th end of budget year. So the results, borehole characterization, the Geological Survey went out there and hit it as hard as they could with all their tools and making a fairly long report summarizing it. They found fairly minor fracturing in the upper 30 to 45 meters. So fracturing, kind of like a fractured skin close to the surface, and then just decreased with depth. And then they also went in and collected water samples with depth and hit it with a hydro lab or I forget the name of it. And coupling the minor fractures with that data, they found basically low conductance water, near the surface and young tritium ages. And then as they moved to the bottom of the borehole, they found like a really brine influenced in old water. And then there was just intermediate mixing, and that really mixes depending on what's coming in from rapid recharge and then just how often they're running that pump. And we also basically determined that deepening the well casing would probably likely limit the amount of that young recharge that's coming in through those upper fractures, but in doing so would probably make the well unuseful. So we did do a number of different groundwater chemistry techniques. So the stable isotopes that I showed you earlier, I highlighted that little orange set of wells, and those wells were nowhere on the evaporative trend. So we don't feel that the lake is influencing them at all. There was no evaporative signature in the groundwater wells, even though they're in very close proximity to the lake. And then the groundwater chemistry we collected over a bunch of different months, and there's large variability in the major ion chemistry and field parameters. So There's just a lot of mixing going on. So when you get a recharge event, you get this low conductance water going in there. And so that really matches kind of with what we were seeing there. Large variability due to how often the well's pumping or how often recharge events are basically recharging that well. And then the tritium sample at the one well 3, which was not the target well that the dye was shown, we did find very young modern tritium age there, but there was also excess terragenic helium, which suggested a really old age to that lower brine water. So the stable isotope chemistry, what am I making? Oh, okay. So not a lot of people here don't work where there's snow, and snow is roughly about 2 times isotopically lighter than summertime precipitation. So in Minnesota, snow melt recharge is a really useful tool, and so that's the point I'm making here. The points that are blue are snow melt samples, and you can see they're isotopically much lighter than what you see at other seasons with respect to precipitation. And so then you can use snow melt recharge as a tool. You can collect time series data of stable isotopes. And so for instance here, these deep declines in stable isotopes are for the 2 creeks on site. So up here you have snowpack, so there was 63 centimeters of snowpack, and then starting in late March, the snowpack's basically declining. So we're melting snow, and sure enough, as you would expect, you're getting lighter isotope signature in these surface water features. But for a couple of the target wells, we start to see lighter isotopic signature in stable isotopes as well. So that's one point. We also had the conductivity running at the same time. And so during some of these discrete warming periods, or when we get precipitation on top of snow, we got these instantaneous decreases in conductivity. So no surprise there, just a slug of basically low conductivity water, then it's getting back to that higher conductivity, and then slugs, with associated precipitation events once we're out of freezing air temperatures. And then there's kind of an attenuated response at well number 7. So well number 7 is this gray well. So you do see this decrease in conductivity, but it wasn't these instantaneous drops. It was more of a diffuse recharge. So yes, went through those. And when you zoom into this and look at it at a tighter scale, we were basically seeing snowmelt recharge at wells 2 and 7 within hours just to a couple days. So we're moving a lot of young water through this fractured crystalline rock into these wells in hours to days. And then I'll just briefly go over what Jim and USGS found with their microbial sampling. When they first installed this equipment in the fall of 2020, it was a really dry period. There was a deficit in precipitation. And so these were set to trigger only after precipitation events of a certain threshold, which I don't know offhand. So during those precipitation events, there was a fairly long recharge. It took about 9 days to get microbial detections, elevated microbial detections after a recharge event during that dry period. But then later in that next spring, basically, precip increased, and you had that wetting front, and the microbial detections basically decreased to 2 to 4 days, which was very consistent with what we found with both conductivity and with the stable isotopes. And the microbial, yeah, so then it's basically the same point. So decreases in conductivity, chloride, bromide, stable isotopes, they all were, for wet periods of time, were all very similar in terms of that time of travel. And then a mass balance in terms of the water in the well itself. So mass balance by volume suggests that the young water is really no more than 10 to 20%, but these are really deep wells. So it's a low yield crystalline rock. So these wells are drilled very deep, and they basically act as cisterns. You're kind of bleeding water in from the top. So that low percentage partially is due to just because the well volumes are very large because they're so deep. So zooming in over towards Lake Superior, we're now moving into some igneous rock. And the site is actually the former Finland Air Force Station. It was a Cold War era radar station, and it's located on graphic knob known as Lookout Mountain. It's a Superfund site, and that's why we were able to acquire all this data. But it's basically granite and diorites. And the groundwater flow, as characterized through all this investigation that was done here, is pretty much lateral and radial from the top of that knob. So where did all the data come from? Well, in Minnesota, we'd always heard about some dye tracing that happened in northeastern Minnesota, and the consultant that did the work couldn't share it because it was done for a client. And the agencies that kind of oversaw it, the Minnesota Pollution Control Agency, people would say that they had seen it, but they couldn't find it. And so eventually I figured, well, I'll just do a FOIA request and see if I could get lucky. And I got very lucky because the person called me back and said they wanted, it was a pretty fair rate, but I was going to have to pay them for their time and then pay them for each page that they were going to copy. And she said, but I could give you 2 hours of time. And I said, well, please give me 2 hours, and if you find something digital, please forward it. And she forwarded me a nearly 6,000-page report with some things that we'll go over real quickly here. So methods in this, it's a gigantic report, but there was dye tracing done by Tom Aley, Ozark Underground Laboratories, but then there was a phenomenal amount of borehole investigation done. It's just amazing how much work they did, and then there was some chemistry done as well. And so the results of Tom's work, he did passive sampling, so those carbon detectors that we were just talking about, and he sampled wells and seeps for about 19 wakes. And he introduced the dyes into trenches at the top of the knob. And so he got radial flow, kind of as expected from the potentiometric surfaces. And most of the dye stayed within a shallow system. So, kind of similar to what we saw in Ely, there's this fractured rock that becomes more and more competent with depth. And so most of the dye stayed within that shallow system. But some dye, at least in the northern portion, was detected in one of their deep wells. And he had rapid rates, so roughly 100 feet per day. So definitely more than what they were expecting based on some of their models. Trying to make all their rock characterization accessible, and especially in particular to fracturing with depth, we took a bunch of their reports and integrated it into this single figure. And basically what they found here is similar to what MGS found at the Ely site, that the fracture zones are really closer to the surface. So here you can see there's kind of inflection points in that cumulative fracture frequency, so you see less of that fracture frequency as you go with depth. They also did a lot of other rock work, and mainly that the apertures were really small. That's the key point here. We're talking millimeter size apertures, but enough to move water through quite rapidly. And then they did flow logging in 6 of these boreholes that they had there. And they did measure flow in 2 of those 6 wells, but then they went back and slug tested the 4 wells that had no flow. And they determined that those 4 wells that had no flow with flow logging were in contact with the fracture system. They just happened to be above the water table at the time of that work. So basically it's, they're kind of draining this radial knob. So they went back and slug tested it and said, well, they are actually in contact with this fracture system. And then lastly, chemistry, which is not summarized very well in the report at all. It's in just hundreds and hundreds of tables in the back. But the summary did say that they detected VOCs and metals in their local or shallow groundwater system. And that's consistent with just kind of the fact that it's a Superfund site. They just were having poor contaminant management, and it got into that shallow detection zone. So they were finding it in their shallow system. So kind of summarizing, karst characterization methods that we've learned over decades in Minnesota in the southeastern portion of the state can be applied quite well to the fractured rock terrains of northeastern Minnesota. And that by combining multiple and disparate techniques at the same time, it really helped increase our data interpretation. The techniques used in northeastern Minnesota revealed discrete, shallow, and deep flow horizons, both at the Archean rock or in the Proterozoic rock. And they have very distinct chemical signatures, whether you're in a shallow zone or in a deep zone. and that the findings from this work will help us with improved water resource management in the Arrowhead groundwater province. We're basically getting ready to start county-wide groundwater investigations in that neighborhood starting this summer. And so this will at least help us with our conceptual model before we go out and sample hundreds and hundreds of groundwater samples. So, thank you. This was a field work friend in 2019 when I was at the Ely site on the road to the location. Any questions?
Yeah, thanks again, John. Any questions out there?
I'm sorry, I'm going to have you repeat that with the microphone.
Apologies. Was there any remedial action done on this site for
Yeah,
all these
there's been-
contaminants? Because it seems like there would have been additional geochemical characterization if they had done a remedial action plan.
Yeah, I'd be more than happy to share that report with you. Like, there's definitely been a lot of remediation done up there, and without a doubt, there's more work. But you know, I don't ever want to look into those 6,000 pages more than what I saw with the borehole characterization and Tom's findings. But I think it would have been remiss not to at least mention a little bit of chemistry. But I could happily share that with anyone who's interested in it.
Well, first off, full disclosure, I'm a consultant myself, and I'm familiar with not that report, but many reports of that size, so kudos to you for having to sift through it. My question, though, is doing a lot of work in fractured rock as well as karst, and what we often run into, I liked your chart on the fractures decreasing with depth. Have you looked into any biasing in the data? Because some of the things we find is, you know, the deeper you drill, the more it costs. So the deeper data tend to be less robust. You have fewer data points. I'm not arguing that fractures decrease with depth in general. We do see that, but I was just curious if you factored that into your analysis. Because again, what we find is that you have a whole bunch of shallow data from shallow wells, but there are fewer deeper wells in your data set typically.
Yeah, so I can only speak to 9 wells that I'm presenting here. So 3 at the Ely site, and those were all around like 500 to 600 feet deep wells, and so the apparent thickness of the apertures, they corrected, definitely were decreasing and becoming mineralized with depth, and they were definitely more in that upper surface. So that was 3 through the borehole investigation through the Minnesota Geological Survey. What was done at this site was robust rock coring at those 6 locations. They weren't all super deep. You could see you could actually see distribution there. But they went through and did something called BIPS analysis, borehole image processing system. And so they went back and took photographs of all these cores, and then they used this like cumulative number of fractures per unit length analysis. And so that was a summary of BIPS analysis, but again, it's for 6 wells. So I'm just summarizing a summary basically for an area where there's almost no information available. But I definitely understand your point. If you've got 5 shallow wells and one deep well, that would be some fuzzy math. Yep. On which location?
Can you figure out the discharge, how much water was flowing in that crystalline rocks? Was a lot?
Yeah, we haven't done that yet because we're still working on our conceptual model. We're basically trying to figure out like what the capture zones are for these wells, because we're not finding our dyes rapidly, yet we're getting stable isotopes, snow melt signatures very quickly, yet we're not getting stable isotopes, evaporative trend isotopes. So, and even just the geometry of the site, there's kind of a ridge, It comes down to the site, and then there's a lake. Yet we're not, we're not like, yeah, we're not really quite sure. So I can't tell you what that number is, not yet.
Just one minute. I want to say, when I was in Romania, I'm originally from Romania, I worked for a hydropower station. And they have two reservoirs. They moved from one reservoir to another. And they built a 200-kilometer tunnel, was the size of this room, and through crystalline rocks. And we hit rivers with 5 cubic meters per second of water coming from crystalline rock. I don't know even today from where that water is coming up.
Yeah.
In this way, we are talking about karst continuously, but in crystalline rock, it's, definitely was a fracture. There was no, but it was rivers coming in, and it was a big problem for those folks. Thank you.
Sure.
Good job.
Yep.
All right, thanks, John. And up next, we have George Ponta, and be doing hydrogeological investigations of the Tuscumbia darter habitat in and near Jaya Springs in Redstone Arsenal, a U.S. Army facility in Madison County, Alabama, USA.
The antenna doesn't point out when it's in the pocket, so that's pretty sure why there's some static.
Okay, sorry.
You're okay.
That's the pointer. Okay, my name is George Ponta. I'm originally from Romania. I have a bad Alabama accent, being there for 30 years, thanks to Jim Lamoro. The title, I work with the Geological Survey of Alabama, Groundwater Assessment Program. The title of my presentation is Hydrogeological Investigation of a Tuscumbia darter habitat in and near Yaya Spring on Redstone Arsenal, which is a U.S. Army facility in Madison County, Alabama. Several people in this room, they are working in the same Redstone Arsenal. They worked before, or they are working even today. The co-authors of this paper, they are a group of biologists, two from Geological Survey of Alabama, Stuart McGregor and Rebecca Bearden, and Christine Easterwood, she's with Redstone Environmental Management Division. To the what? Okay, it's working. Cave ecosystem in North Alabama provide vital habitat for the state of Alabama highly conservation priority, Tuscumbia darter, which is a little fish. You can see it's 40 millimeter or about 1.5 inches. This Tuscumbia darter is known to occur within Redstone Arsenal boundary, including Yaya Springs. Current industrial development in the city of Huntsville and Madison is pretty extensive. In this moment, there are about $3 billion investment. Toyota plant, Facebook and Amazon, everybody is building and is moving to that city. In this way, the possibility that the recharge area for this Yaya Spring to be contaminated is pretty high. And the Redstone Arsenal environmental program ensure military missions activities are conducted in compliance with all applicable environmental law in the United States. Here is the map of United States. Then Dr. David Drew did it. Alabama is located in the southeastern part of the country. And Redstone Arsenal itself is located in Madison County on the Tennessee, along the Tennessee River and along the Tennessee state line. This is a geologic map of the area. Approximately, the location of Redstone Arsenal is here. And in the north, east, and west, it's surrounded by the city of Madison and Huntsville, and in the south by the Tennessee River. From the geological point of view, the site is located in the Highland Rim physiographic province, which is, and the site itself in the southeastern corner. And from geologic point of view, the bedrock geology, the most of the area is covered by the Tuscumbia limestone, and underneath, along the creek at the lower depths, it's four-pane chert, and on the ridges, Monteagle limestone, Bangor limestone, and Pennington Formation. On this geologic map, I put a yellow line, horizontal, east-west. South of this, north of this line, it's the allogenic recharge, and south of this being autogenic recharge area. This line basically shows sort of the northern limit of outcrop of four-pane, or Tuscumbia limestone, which is the main aquifer at the site. The site, the bedding, it's pretty much horizontal, which actually is generating a very slow flow along that bedding pay along the site. The site, it's covered by an overburden or regolith, which thickness varies from the yellow color, it's about 20 feet on the top of the ridges, which is about 7 meters, and to this light green color, where it's about 80 feet, and that means about 27 meters. The only places where you can when you can find rock, outcrop, it's at in the caves or cave entrances at the site. Here, it's a Karst hydrogeologic map, which I did it, and I used for the limestone, a range of pink colors, and most of the site, this medium pink color, let's say, is Tuscumbia limestone, and along Indian Creek at low elevation, it's four-pane chert, and on the ridges, you can find Monteagle and Bangor limestone. A few words about this legend. I modified the international standard legend. In the original standard legend, the limestone were included in this category, fissured aquifer, where they are using a range of green color. And to me, was much easier to do it, to figure out the limestone on a map, on a hydrogeologic map, and I use this set of, I made an additional category in groundwater and karst aquifer, and where it's highly productive, moderate, and local discontinuous productive. This map, this legend, I generated when I was in Romania at the Geological Institute, and we started doing this Karst hydrogeologic map. And in Romania, like in Spain, the majority of limestone are Triassic and Jurassic age, and this color was most appropriate for that purpose. Now I extend it in Alabama too. Here it's a cross-section, north-south along the site. It's a vertical exaggeration, it's 40 times, and the cross-section is showing the bedding plane, which is dipping south-southwest, about 6 to 20 meters per kilometer. That is 0.33 to 1 degree deep. This is horizontal. The water level elevation, we measured in the cave and demonstrate the south trend of the water tables towards Weir Lake, Tennessee River. Now to go to the target of this project, it's Yaya Spring. Yaya Spring, to protect this little fish, we have to define the recharge area of Yaya Spring. On this map, the green, I defined the recharge area based on the 7.5 minutes map in the old fashion, which is the scale 1 to 24,000. For the Europeans, it's sort of equivalent of 1 to 25,000. But at the same time, I used the USGS program, StreamStrat, and to be honest, was 99% identical. In this way, the program and my recharge area was almost the same. To better identify potential area of groundwater contamination, we subdivided the Yaya Spring recharge area in 7 watersheds, sub-watersheds, and I labeled those RA1 through RA7. Here, it's an example. RA4, the example, was in the middle of a pasture field with a bunch of cows, and here is during the dry season, in the middle of the summer, and here it's after 5 inches of rain in 2 hours. Here is the same thing, the pasture field before and after the rain. That pasture field, between the sinking point and the spring itself, it's about 1.5 kilometers, and I consider that it would be a good buffer zone to protect the Tuscumbia darter in that spring. Here it's another example of RA7 before. Now, in a couple of locations at the site, I installed transducers, time series water level, temperature in 2 of the other conductivity. In those locations, and I collected data on an hourly basis for 7 here is the cave. It's a small cave, bobcat cave. In this bobcat cave, we have one of the endangered little crayfish. It's a water table cave. It's no stream, like you see. The cave entrance is in that point. Our transducer, the end of the transducer, is in that point. This is during the dry season. It's very muddy. There is the end of our transducer. And the other end is at the land surface, and is transmitting the data to our office on an hourly basis. We are using OTT Hydromap 800. I don't know if you are familiar with those devices. And at the end of, this is the other cave entrance, Matthews Cave, and there is the device which is transmitting the data to the office. This time, the cave is developed on a fracture, north-south, and there's a cave entrance. A stream is flowing through the cave from north to south. Here is our device installed at about 100 meters into the cave. And an interesting fact about this cave, the yellow line shows the Interstate 565. The cave, it's going under the interstate, and definitely the DOT, when constructed the interstate, they knew about the presence of the cave, and they tried to reinforce, and they drive into the limestone beams. And 2 of the beams ended up in the cave. It's a picture of one of those, how they look today. And, additionally, I'm monitoring continue 2 wells at the site. And this is the spring itself. The headwater of the spring, actually, it's about 1 kilometer long swamp with numerous seeps. You cannot go into that swamp. It's very dangerous. It's very wet. It's moving sand. Plus our rattlesnakes, they are everywhere. And this spring is monitored continuously. And based on those monitoring data, plus another 12 wells we measured on a monthly basis, we generate water table map, which is going towards south, towards Tennessee River. This is one is in dry season, and the other one it's in the rainy season. And with all this data, we generated several graphs. On the top one, it's conductivity. And here I show on the graph only in the Matthews Cave, it's that line, and I show only Bobcat Cave. You can see Bobcat Cave in a couple of areas, the device quit working, and in between we replace it with a new one. And also on the top graph, how many times we went to Yaya Spring, almost, and here it's a red triangle. We measured the discharge of the spring itself. And one of the lowest discharge was by accident, the very first one, which is an important, just keep in mind that was, I don't remember, 2 or 3 cubic feet per second. On the middle graph is the water level elevation, The first one, it's the well, it's in the vicinity of the Matthews Cave, and you can see both, they are, the water level mimic elevation is about the same, and I personally believe that the well was installed in the same aquifer. And the middle graph, that light blue color, the graph is the water level of Indian Creek. The data, we downloaded from the USGS website where they have a station there. Also, from the same station, we have the precipitation data. That site, the USGS site, it's right across on the interstate, at the end of the cave, basically. Bobcat Cave, water elevation is here, which is very similar with the other well. And here, in dashed line, we have the Yaya Spring water level elevation. Due to scale effect, it's almost a straight line. And the last graph is Tennessee River water level elevation, Wheeler's Lake. This data, we receive it from TVA, Tennessee Valley Authority. Based on this graph, we can see that all this water, the entire aquifer, is discharging in the Tennessee River. Now, the precipitation graph, you can see that if the water level elevation, actually it's directly related with the amount of precipitation, due to dilution, the graph of conductivity is the other way. Where you have a lot of rain, the conductivity value is going down. Here, we collected about 50 sets of samples during 2 or 3 years, and we analyzed it for numerous constituents. I'm going to spend a few minutes just on the nitrate. In this graph here, you can see the red line is the concentration of nitrate in the Yaya Spring. That buffer zone, which I mentioned, has no effect on the concentration of nitrate. All the other graphs, actually, all this other line represents the concentration of nitrate in those RA1 to RA7. The middle graph, this time, I changed the scale, and this is how the water level elevation in Yaya Spring looks like. And definitely, it's in correlation with the amount of rain. Another graph is the E. coli graph, is here versus on the E. coli graph versus the nitrate. This is the Yaya Spring E. coli bacteria concentration, and we can see that the buffer zone is filtering some of the E. coli. The other sampling point, the quantity, the numbers of E. coli bacteria is much higher than in Yaya Spring itself. Now, another item which we did at the site, the two caves, one well and Yaya Spring, were sampled for radiocarbon. The radiocarbon analysis was performed at the University of Georgia, and those are the location. And the quoted uncalibrated dates have been given in radiocarbon years before 1950, using carbon-14 half-time, 5,568 years. Subsequently, these data were calibrated and corrected to 1950. And surprisingly, we have the age of the water in the well came out to be over 20,000 years old. In those two caves were 2,800 and 2,700, and in Yaya Spring was about 1,000. Hold on, it's not there. 1,200. And we go back when by accident, like I said, the very first sample when I collected here, I have the lowest flow recorded in over 3 years at the site. And more than likely, I'm near almost 100% sure I collected groundwater. And that is, to me, one of the explanations for the age of that water. And for the same reason, I'll present some data with studies to see how complex, even a geology, let's say it's very simple in horizontal setting, but the hydrogeology is very, very complex. Here, For example, in the 90s, Geological Survey of Alabama, they injected some dye south of Bobcat Cave, about 500 meters, and the dye, instead to go southwards toward the Tennessee River, was found in the cave. This way, this horizontal plane more than likely has a sort of depression occasionally, and the water was the other way. In 2003, on the same property, on the same Reston Arsenal, Shaw Environmental performed a study. They injected the dye in a well, and the dye went southward, but the dye went everywhere, so east, west, north, and I don't know from the report, like in the other case, I have 6,000 pages of report. It's very possible that some of the wells were under pumping condition. And the most recent dye study performed was in 2017-18 by PILA. They injected dye in four different wells with 4 different dyes, and they work together with Tom Aley. And the most interesting result was the dye injected in this well show up on the other side of Indian Creek, and was the first time when they proved that actually it's a continued aquifer of Tuscumbia aquifer under the creek. Another fact, these are the numbers in milligram per liter. In this way, 3.5 years after the dye injection was performed, just about a month ago, I collected with a baler a water sample from each injection well. The highest concentration was 98.2 milligram per liter in one of the wells. That was in 2021, and this was about a month ago. In a way, the dye is still present in the well. Last year and this year, I put charcoal bags in the cave in several springs, and was analyzed by Tom Aley because he did the work for PILA. And as today, the system is clear. We find last year and this year. But talking to Keith White, it's possible to find the dye 20 years from now. At the site, in the vicinity of the site, was performed a lot of dye studies. And these dye studies, on this graph, I have the groundwater velocity in meters or feet per second, and the distance traced. And the lowest number I found was 0.14 meters per second. Here, I put the numbers in meters per day. The lowest number is 8.64 meters per day. The middle one, the average is 86, and the more fastest one was 864 meters per day. This way, another component of this age of the water, to me, is extremely slow travel time along the site. Here, it's one graph. It's a Wilcox graph. It's irrigation criteria. On the graph, we have conductivity versus percentage of sodium. And you can see, based on this data, the site is pretty much clean, except our well, which is unsuitable. This way, Tuscumbia darter population, Yaya Spring, has remained stable during the 2-year study period. Through our study, found that some water quality parameters like E. coli and nitrate had elevated values, but typical with this condition. And at the current rate of application, the recorded variation in water quality in the study area do not appear to have an effect on the Tuscumbia darter population. And if you have any question, that's the answer. Thank you very much.
Thank you, George. Any questions?
So, George, is this considered resolved now that there isn't going to be any impacts, or where is it sort of left?
As today, yes. But what is going on around the site, it's very possible that the condition is going to change. The Reston Arsenal is under pressure to, to give away to the city. They have not too many options where to move with their development. And, we are trying to, with this little fish and a little crayfish, to try to protect that area. And I don't know how it's happened, but it's a lot of activity at the site. Now FBI is moving to the site, 7,000 people. The Space Force is moving. As today, at Reston Arsenal works 40,000 people, as today. In this way, it's a very, very, very big installation.
All right. Thanks, George. This concludes the hydrology session.
All right, folks, the ASTM roundtable is going to be starting in about 10 minutes. All right, good afternoon, everybody. This is the ASTM Karst Panel, and we're going to be talking about the new Karst Committee on ASTM. First speaker, Gene Asquith.
Okay. Welcome to the ASTM Karst Panel discussion. My name is Jeannie Asquith. I'm from Easterwood, New York, just south of Buffalo, and I'm a licensed professional geologist in Buffalo. I own a geologic services firm, and in addition to that, I own a soil, rock, and material testing laboratory. As such, I've been a member of ASTM for over 30 years, being that we use the standards in our laboratory and in our work every day. My ASTM career has been busy. I started out working in subcommittees as officers and started working on standards and quickly became pretty involved in the group, and then was nominated to the executive committee of D18 on soil and rock. Well, when you're on the executive committee of D18, you get assigned tasks that are above and beyond your other duties. And my most recent task was to work with Gheorghe to determine if a Karst subcommittee would fit into our group. And voila, we're here. George was successful at getting our group to accept a Karst subcommittee. So we've been busy. And so today I'm going to tell you about ASTM and how D18, our committee, and our subcommittee on Karst fits into the whole picture. So, next. ASTM is an international standards development organization located near Philadelphia, Pennsylvania. ASTM has been developing standards for over 116 years and has over 12,000 standards globally. I'm sure you've seen ASTM standards printed on PVC pipe and other commercial products. ASTM collaborates with businesses, governments, and experts worldwide to create standards that combine market relevance and technical quality. ASTM standards harness our over 30,000 members' expertise and commitment, building on good science, engineering, and judgment. There are 148 technical committees that create standards that influence the entire industry. Some of those technical committees might be fire, ski safety, cannabis, soil and rock. There's a whole pile of them. In addition to that, you've probably seen ASTM standards in contracts, laws, and regulations. If you work with EPA documents, which I'm sure some people at least here have, you've seen EPA standards referenced there, as well as probably your own technical specifications. ASTM, the principle that makes ASTM trusted and accepted worldwide is openness. ASTM brings together experts, individuals, organizations, academia, governments, trade associations, consultants, consumers from all over the world. Exchanging expertise and knowledge, ASTM's over 30,000 members participate in a transparent process that's open to anyone, anywhere with an interest in a standards development and use. It is vital that ASTM stay relevant to users' needs. All standards are reviewed every 5 years. They can be reviewed sooner, but they must be reviewed every 5 years according to the regulations. ASTM's standard process is flexible, transparent, and built on consensus. In addition, ASTM is constantly trying to improve their own standards development tools, member databases, and member connectivity methods. Sorry, I got distracted. So that keeps members in more instant contact so that they can develop standards more efficiently. And that's a good thing for ASTM. That reinforces ASTM's reputation for timely as well as relevant standards. How does the consensus process work in ASTM? All members have a vote, giving everyone the chance to participate in the process. Balance is maintained at the main committees and subcommittee levels by assigning members a classification. There are classifications of user, producer, general interest, or consumer. The number of producer votes must always be equal to or less than the total number of the other three, keeping the balance of the producers. So, for example, I would be classified as a user since I use the standards in my work every day, and probably most people in this room would be users. Equipment manufacturers would be classified as producers. So your balance is maintained. Boy, that is troubling. Oh. Got it? There we go. In D18 and all ASTM technical committees, the goal is to stay relevant with current technologies. Oh, there you go. Yeah, that's right. So if a member sees the need to revise or develop a standard, or if someone outside of the organization does, there's always a way to do that. Why does it keep doing that? That's not what we want. Yeah, seriously. So anyone at any time can come to our group and suggest that they would like something changed. And all they need to do is come to the ASTM subcommittee meeting and get consensus on what they would like to do. Once they have a draft standard in place, it moves on to the subcommittee for balloting. Okay, so the balloting process in this slide works from the bottom up. All work is done at the task group level, and task groups are informal. There's no official voting that occurs, and anyone can participate in task groups. Once your draft standard is developed, it moves into the subcommittee ballot phase, where it goes into official balloting. If and when it passes the subcommittee ballot, it moves on to the main committee balloting process. At any point, if a member votes negative, it stops the process. If the negative is found to be persuasive, you rework your item and then resubmit it for balloting. If the negative is found to be non-persuasive or not related, the motion, the vote count, and the rationale go to the Committee on Standards to be sure that the regulations have been followed. So it's quite a process. I've seen it work very well. So here's a list of a few more of our ASTM committees. You can see the wide range of content that ASTM gets into. So if anyone who wants to use their expertise to influence standards is welcome to do so. So D18 on soil and rock was formed in 1936. We have 23 technical subcommittees with nearly 1,200 members. We have jurisdiction of over 365 standards with 40 or more in the development process. And we meet twice a year in January and June. Some of our meetings are hybrid, so you can attend online sometimes. And then you can see by the numbers that D18 is actually one of the larger committees in ASTM. D18's scope of work includes test methods, specifications, guides, practices, and terminology. Some of the subcommittees that may be of interest to this group are karst, groundwater and vadose, and hydrologic properties. And then some of our 365 standards, we have drilling guides, we have sampling guides, we have air permeability, water permeability, sieve analysis. We have a lot of tests, 365, so name what you want. All right, our D18 membership includes, it represents many different entities, such as consulting geologists and engineers, government agencies, equipment manufacturers, academia, and private end users. Now, I have met a lot of people through ASTM, and the technical exchange is great for your business, for your career. I've just enjoyed the process immensely. It's been a huge boost to me and my business, and I just find I've met great friends through the organization. We keep in contact, so I can reach out to so many people and get help. Here's a list of some of our subcommittees. Not all are here because I couldn't fit it on the slide, but you can see there's quite a smattering of topics. So maybe in this room you might be interested in surface and subsurface characterization, sampling and related field testing, rock mechanics, deep foundations. I've already mentioned karst, groundwater and vadose investigations, but not listed here, but should be, it's hydraulic fracturing. So anyone can be involved in ASTM. The annual member fee is low at $75 a year, and in addition to the benefits that I've already mentioned, you get a free book of standards every year. Now, I've been a member for over 30 years, so I have a literal library of standards. It takes up a lot of space, but it's okay, because it really helps with proposals, testing, and assisting clients. And that alone has been a huge boost to our business. If you've ever tried to buy an ASTM book of standards, I think they're around $400, so it's a good value. It doesn't cost anything to go to the meetings, and anyone can attend or anyone can join at astm.org. But you can also attend it as a visitor. And I also wanted to mention that there's a student membership as well. So this panel is made up of ASTM members, and you'll be able to ask questions when we're all finished speaking. But we have a link to ASTM, and her name is Katerina Kaperna. She's a fantastic resource if you guys stump us today on our panel. So all committees have a link to ASTM. Thank you for your time, and hope to see you at a meeting soon.
All right, next speaker is George Venny.
Okay, let's see. There we go. So I'm going to focus on D1827. D18, of course, is the committee, 27 is the subcommittee, and it's on karst. I will talk about how it was formed and what the scope of the committee is, and then some of the other speakers will, the rest of the speakers will then talk about some of the details of what we've been up to. So, going back in time, as far as some history, the first major connection, at least that I'm aware of, between ASTM and karst was in 1995, when a standard that's known as D5717, the proper name of it is Design of Groundwater Monitoring Systems in Karst and Fractured Rock Aquifers. So that was approved in 1995. Wrong button. The major contributors, there are many people involved, but Jim Quinlan, Gareth Davies, Maureen Muldoon. It was based on a report that Jim Quinlan and Ralph Ewers, and Ralph is here at the conference, he was co-teaching the dye tracing short course, on a report that they did, and in '89 it became an EPA, it transmogrified into an EPA guidance document. This was really important because people had just started doing work in karst, and most people really didn't have much karst expertise. And it's still the case to some degree, now, but it's not as bad a situation as it was in the 1980s. The standard itself, though, in talking to those people involved, they felt it was a bit of a compromise because it included fractured rock and not just karst. In the 1980s, the 1990s, karst was still not recognized in some people's mind as a valid science. It was kind of like, well, I don't know, it's kind of weird. And certainly some of the people working in it are weird, present company included. And so it was kind of pushed on them that they needed to include fractured rock. And that happened, and it still went on. It was a good document. But after 8 years, it was withdrawn. As Jeannie said, after 5 years, it goes through a review process, all the standards. And this is a good thing. You write a book, and you say, okay, this book has been written, but the information in there gets out of date, as the standards do. And so if it's not reviewed, revisited, reapproved, then it goes away after 8 years. And that's what happened with this one. Meanwhile, since that happened, I'm not aware of any karst-specific standards that ASTM passed. There were some that kind of touched on karst here and there, but nothing is certainly as dramatic, as significant to karst as this one. So the reawakening of karst standards actually didn't start with ASTM. There are two international standards organizations, ASTM being one, ASTM International, the proper name, and then there's ISO, the International Standards Organization based out of Switzerland. Well, they were approached in 2017 to create Technical Committee 319. It was created in 2018, and it was going to be a technical committee on karst. Its purpose was, and I know I'm talking about ASTM, but this is relevant here. Its purpose was standardization in the field of karst terminology, sustainable development of karst resources, environmental protection, management of karst environments, as well as investigation and assessment, including modeling methods and mapping of karst systems. And it was sponsored by the International Research Center on Karst, which is based in Guilin, China. And at the time, I started getting a flood of messages through my dual roles, partly as the executive director of the National Cave and Karst Research Institute, but also at the time I was president of the International Union of Speleology. So many people were concerned, what does this mean for us? Is it going to be well done? And I said, well, you know, I've worked with the folks. I'm on the advisory committee for the IRCK in China, you know, but what does it mean? And so there was encouragement for NICRI to get involved and see what, you know, in this process. So ISO is different from ASTM in several ways, one of which is membership. I can pay my $75 and become an ASTM member. You know, it's relatively cheap. And I'm a member directly. But to be a member of ISO, individuals are not members. National standards organizations are members. And so in the US, that's ANSI, the American National Standards Institute. Each National Standards Institute is different. In the US, it's really difficult to be involved because I said, okay, what does NICRI have to do to join ANSI? They say, well, it's cheap, it's easy. It's only $15,000 to join for the first year and then $10,000 for all the subsequent years. It's like, that's not in our budget. No way. You know, so, okay, now what do we do? There's going to be this International Standards Committee on Karst. You know, I think the US should have a voice. Should be involved to some degree. So that's when I contacted ASTM because ASTM is a member of ANSI. So in talking with the good folks at ASTM, you know, we worked it out. The way to make it happen was that we would create a karst subcommittee in ASTM, and then that would liaison with ISO, with their karst committee. And so it would give us a way of working together. That unfortunately didn't work because ISO still wants a lot of money. They wanted, I think at first they wanted $565 a year, and I thought, well, NICRI could kind of cover that, you know. And then they upped it to like close to $1,300 a year, so they make it really expensive. You know, I shouldn't say ISO, ANSI wants that money. But the idea was that we would, you know, have this good liaison, avoid duplication of efforts, you know, be aware of what everyone's doing. But anyway, so we created, you know, D1827. And here's the scope. We were created in June of 2019. Our first meeting was in February of 2020. And the scope is to develop standards that assist and or guide the protection of karst and pseudokarst resources, and that assist in the understanding of geohazards accompanying those systems and further use of karst that includes pseudokarst. This responsibility includes standards relating to the classification, characterization, and properties of karst systems and processes. Standards involving associated site characterization, geologic, hydrogeologic, and geotechnical aspects associated with potential and or actual ground instability are included, and we'll coordinate with standards development with other committees and subcommittees where there might be overlap. Now, that's the scope. That's the goal of ASTM D1827. My personal goal with this kind of goes back to the original, you know, D5717. The problem that we often see, and many of us are aware of people who are intelligent, well-meaning people who go out there working hard in karst, but they have no experience in karst. I mean, when I worked as a consultant, frankly, I spent a lot of time fixing mistakes that other people did, you know, and that's unfortunate, you know. And so by creating standards, and if you're not aware, many countries, many agencies, many organizations say, well, if we're going to do this, let's follow the ASTM standard. So they use ASTM as the reference. And many consultants who are not aware of how to do something, if they don't have expertise, they will go to ASTM for guidance. And so this way, we have essentially a series of guidance documents that anyone can follow. And so even if they are not karst experts, but they're still doing the work, they will do a much higher quality piece of work, piece of research. So if they're going to do it, let's try to support them to make sure it's done as well as possible to best manage, understand, protect these cave and karst resources. So that's my personal goal with creating this subcommittee. So, status report. What's happening with ISO is not much. There was a meeting just before the pandemic in China, and it was just mostly an organizational meeting. To the best of my knowledge, they've only had one virtual meeting since then. And the last thing I heard, which was about 6 months ago, they're talking about developing standards for cave clothing, which is okay. I thought you were talking about, geotechnical, geophysical, whatever. But, cave clothing, I mean, there's detailed measurements of measuring the arms and legs and okay, whatever. But nothing, as far as I know, nothing's really moved. So the rest of this slide focuses on what D1827, the Karst subcommittee for ASTM, has done. So we've had 7 meetings since we were created. Our first membership had 24 people. We've grown to 62 people. Additionally, we have 15 non-ASTM members who participate, who give us their feedback. So as Jeannie mentioned, you're not required to join. We welcome feedback. We want ideas. But ultimately, if you want to vote on the standards, you have to be a member. But in the meanwhile, you can certainly be highly involved in the process. We have currently 5 task groups working on specific standards and topics. And the potential for more is really huge. I mean, think about what we've heard during this conference, all the many different topics and issues that are going on. So many of these things can be developed into useful standards to help guide our profession, to guide people who are not in this room, in this conference, to do a much better job, not just nationally, but around the world. Our next meetings, and there's more than this, but the upcoming one is in Denver in June, followed by Louisville, Kentucky in January, and then Philadelphia in June of next year. So with that, I will pass it over to Steve, who will talk about our Karst Terminology Task Group.
All right. My name is Stephen Meggs with SDII Global Corporation here in Tampa. I'm a licensed engineer and a licensed geologist and also a geophysicist. And going to go over what our task group on terminology has been working on. What is karst? Seems like a pretty simple question, but it's actually a very contentious question. You saw before when asking what a sinkhole was, how many people had different opinions on that. And that's what we're running into with the term of karst. All these photographs show different forms of karst. We have the top right, we have tower karst. We have a cave, and we have a sinkhole. Karst is not just one type of lithology, and it's not the features that result. And there's so many different features. How do you combine them all into one? Ultimately, it's the geomorphology, the hydrology, chemistry, all of those together. Well, all of those, but how do we put them all together to incorporate as much as we can and remain with a consistent definition? Ultimately, the terms that we're trying to develop are going to be those that are used in our standards. Caves, conduits, a sinkhole. We're working on a definition for that. And of course, we disagree a little bit here and there. We're not trying to include caving terms such as pit, stalactite, because we're not going to be using those in the standards, or are unlikely to. And we aren't going to be including well-defined terms that are used in the rest of the 18, like permeability, porosity, terms that are already defined. Right now, we have 45 terms. I've got a couple more to add in there. But we need to consider those, what we're going to use in new standards. We don't want them just to be strictly technical. We also need them to be concise and simple. And like I said before, we want them to be practical to the application of the karst standards, so that we can use them in the field. Where are we at? What's up next? Well, we need to finish defining karst, or at least agreeing, get it balloted, and finish reviewing, finding any additional terms to add, to define, and then try to support the rest of the task groups with terms that they may need defined. And that's on next to Mr. Denton. And I would like to say, as many, with all the contention there is about these, it's great to have more people there, offer your opinions. So,
That's the advanced. The top one.
down.
Down, that one. That's advanced. I believe so.
I haven't used this controller before, so if I accidentally go backwards, I'll try to go forward. So my name is Bob Denton, Robert Denton. Everybody calls me Bob. And I'm a certified professional geologist and also a licensed soil scientist in the state of Virginia. I work for Terracon Consultants. You may notice that there it says GeoConcepts. We were actually became one with Terracon in 2018. So there was some of the slides will show GeoConcepts, but we're essentially one company at this point. So the this kind of shows the evolution of how this what I've been working on with ASTM got started. And believe it or not, the first step was right here at the Sinkhole Conference when it was held at NICRI in 2013. And that up there you can see towards a karst assessment standard practice. And what the impetus for doing this was that back in the first decade of this century, there early in the early 2000s, there began a tremendous building boom. And I was called in by quite a few local county boards, the engineering departments, the planning boards, to comment on and give them evaluations on karst assessments, because they didn't really have anybody on staff that could do that. They knew that that was my expertise. And the thing was, I would see things called karst assessments that somebody would go out and count sinkholes, and they called that a karst assessment. Or they would run a few resistivity lines and call that a karst assessment. Or they would do something so elaborate that it was impossible for anyone who didn't have a technical background to understand. Neither of those two extremes would help an engineering staff or a planning board make a decision. And so at that point, I decided to try to think about how could we develop some kind of a standard practice for karst assessments. So this presentation kind of summarized it. We then decided to kind of concentrate on the state of Virginia, working with the Cave Board, a member of the Cave Board in Virginia, which is an advisory board of the governor. And we actually, the primary emphasis there was myself and Dan Doctor, began to put together, and along with Will Orendorff, a standard practice for the state. We finally did get that developed, and it was promulgated by the Cave Board. And I became a member of ASTM in 2020, and that's when, because my dream had always been to have an ASTM standard that would be for standard practice for karst assessments. Let me see if okay, I hit the wrong one. There we go. So why perform karst surveys? And simply enough, we've got construction issues. I'm not going to read this whole book on a wall here, but obviously, you've got the bedrock interface, the soil bedrock interface, sediment erosion control problems during construction, sinkholes, flooding, regulatory issues. This is a real big thing that really concerned us, was that the planning boards of the jurisdictional engineering departments, began to require karst surveys for all industrial and commercial development. And the heavy emphasis was on sediment erosion control during construction, as you could imagine. The karst environment was also the habitat of numerous rare, threatened, endangered species in our region in the Shenandoah Valley. The most heavily protected one is the Madison Cave isopod, which lives in the phreatic aquifer, the deep aquifer, but we also have the Indiana bat and other species of bats that are protected. It's interesting to note there are currently 28 states that have cave and karst protection acts in place. Virginia's was the first, and the other states began enacting them shortly thereafter. Most of them are very similar to Virginia's, but the bottom line is the characteristic of karst features and location patterns are used to focus subsequent subsurface investigations. So we have a two-phase approach. We have a preliminary investigation in the method, and then a detailed investigation. Our method that we're writing right now really deals with the preliminary, what we call the preliminary investigation, the first investigation. So the qualified individual, we decided that, at least in our Virginia standard, and this is straight out of the Virginia standard, it's based off of the Clark County regulation, a county level regulation. But we wanted to say, who can do these things? Can anybody go out and do a karst survey? And so what we decided, that has to be a CPG or a PG, licensed geologist, licensed civil engineer, geotechnical engineer, but they have to have specific experience in karst characterization. And there's kind of two levels. The field work can be done by what we call a karst field geologist, and then the oversight and basically the person who would sign and seal the report would be the karst specialist, who would have a little bit more experience and at a higher level. So the recommended scope, this is just what we would see. If you went to my shore course, you would see we gave a more elaborate description of all this. But site description, terrain analysis, delineation of major surface drainages, description of published soils and underlying bedrock, location delineation of major karst features and drainages, including, of course, sinkholes, caves, insurgences, resurgences, losing streams, the potential for covered karst inferred location of shallow bedrock. And one of the important things is a site is karst even if there are no surface features, but it's underlain by karst bedrock. And that's really important, because I've seen many karst surveys where they said the site was not karst because they didn't find a sinkhole. And that's not the case. So suspect karst features, we do this desktop data review first. It's the first step of the process. And there we look at various different data sources. It could be tufa contour interval maps, DEMs, aerial photographs. The most powerful technique we have these days, of course, is LiDAR. And LiDAR is really, it was when we first started this process back in the early 2000s, there was veritably no LiDAR coverage in the United States. And now we've got LiDAR coverage across nearly everywhere. Even in Virginia, we had very little. Today, you can get good, high quality, high resolution LiDAR almost everywhere. But even with all this data, what happens is, at this point, at this stage, because it's a desktop data review, anything we find is still considered an SKF, which is an acronym for suspect karst feature. It doesn't become a feature, a real feature, until we go out into the field and verify its existence. And the reason is that you look at LiDAR. LiDAR is such high resolution that you can see things that are the size of a wash bucket. And so they could be something like an old test pit that partially filled back in, or a tree throw where a tree fell and the stump pulled up the soil and you get a depression. So what we do is we go out, we locate and verify all the features that were found in the desktop review. We locate and characterize previously uncatalogued, unidentified features, and add them to the survey. Document them all, and we document characteristics of these features. I'm not going to go into that. That's a whole presentation in and of itself. But basically, these are what we call characters or characteristics. And things like, does it have a throat or not? What's the shape of the parapet? What kind of a drainage system? Does it have a drainage channel, or does it receive sheet flow? On and on. And we code these things, essentially. And then the coding is all added up. And then within that coding, if it adds up to 0 to 1, it's low risk. 2 to 4, it would be moderate risk. 5 to 6 would be high. And 7 to 8, it would be very high risk. And it's this coding method kind of, I mean, just imagine if you're out at a site and there's, it's 1,000 acres and it's got 700 sinkholes. It would be veritably impossible to write a narrative for each feature. You could do it, but it would produce a report that would be that thick, and it would be unbelievably expensive, prohibitively expensive. So we had to come up with some way of doing a risk ranking that was less subjective, less voluminous, and easier to have compacted into a small space. So the field reconnaissance, what are we looking for? We're looking to verify and locate these suspect karst features, and the pattern of the features location are used to focus a subsequent investigation if necessary. And generally the detailed, so like I said, we have this preliminary investigation and then a detailed investigation with the second phase. Generally the detailed investigation is invoked if features that we have found during the field investigation might be impacted by the proposed development. But a lot of it, again, depends on whether, when we say impacted by the proposed development could be, for instance, there's a sinkhole slightly off-site, impervious surface is put in, and drainage from that impervious surface would actually run off-site and to that sinkhole, possibly cause some kind of contamination. So that's when the second phase comes in. So the findings and opinions would be the outcome of the standard that we're currently, that right now is a draft that's in balloting. And so it includes a summary of the findings and the opinion of the karst specialist for additional studies. And these additional or detailed studies could include everything from, electrical resistivity, seismic, subsurface borings, or anything appropriate to determine if the proposed development can have a negative impact on human health, safety, the property, or the environment. And the investigation should be completely reported to the client or the county engineering staff prior to any briefings or public hearings on the parcel in question. So the detailed study, the follow-up study, is not in the standard we're working on currently. It's strictly the preliminary study, which again, the main elements is the desktop review and the field verification. So the findings, what would be the results? Now think about the phase 1 environmental site assessment. When you do a site assessment, I've done these as well. What are your findings? It's the opinion of the environmental specialist, and it is either there are recognized environmental conditions, RECs, or there are not. It's the same thing here. It would be the investigator's findings or opinion would be if the investigation finds the site is not underlain by soluble bedrock or there's no evidence of karst features, they shall so indicate in a written report provided to the client. Karst features will not be impacted by plan development. If karst terrain is present but no known karst features are to be affected by the plan development, the application need not submit a standalone karst management plan. A statement should be included in the karst assessment certifying that no features will be impacted. And here's where we move to the second type of investigation. In cases where the investigator finds that it will be impacted, that is the trigger to move to a detailed investigation. Find out how it might impact the infrastructure, how it may have effect on human health or the environment, and because we want to protect the karst habitat as well. People often ask me, Bob, when you talk about protecting the resource, what's the resource you're talking about? The principal one is the karst aquifer. In karst terrains, as many of you know, most municipalities and private residences rely on that karst aquifer for their drinking water. If it's affected negatively, that's not a good thing. So that's the first and foremost thing we're trying to protect. But that also tends to act as a habitat for animals that reside there. And so with the completion of the investigation, the client or applicant may be requested to submit a karst management plan by the jurisdictional planners, or state or federal regulatory agencies will be required to follow specific recommendations. And closing, it's our hope, and I am going to read this, it's our hope that this standard practice may serve as a template to assist investigators in conducting a comprehensive preliminary karst assessments and help jurisdictional regulators, engineers, and legislators in determining the minimum elements that should be required or should be expected for a site evaluation. That's the key. The key is that it sets up a standard that says, is running a few resistivity lines a karst survey? No, it's not. You should expect these elements to be embodied in a karst survey, this minimum number of elements. So nevertheless, it must be emphasized the protocols presented herein are not intended to substitute as a detailed subsurface investigation. That's really important. That's the follow-up, or to supersede any existing karst regulations or codified protocols. And that's it. Thank you.
All right, next up, Peter Hutchinson.
From Pittsburgh, actually east of Pittsburgh. Came down here thinking the weather here is pretty nice, but I wish I'd have brought my winter coat. We're going to talk about, this is the part where you guys get involved, is where you get, I guess I should tell you who I am since I gave a talk before, but geophysical company up in the Pittsburgh area. I've been a member of ASTM for 35 years. I've never technically been involved in this kind of a role before. Not really sure why, but I voted on, it's got to be several hundred different standards and methods. And I think everyone here should join. It's only $75 a year. And you get a chance to see standards that are starting to be developed before they actually become standards, so you can understand where the thinking is. And I did not accept one about 20 years ago, and they work with you to try to get that, whatever issue I had, which I don't remember, worked out so that the standard is a standard, meets all the requirements that you would expect out of a task. And so every year I get one of those books. I've got, company's got, I think, 30 or so, maybe a little less, because we recycle the really old ones. But we keep the older ones just to see how the standards have changed. Every 5 years they review them, and sometimes we go back to see what has changed and how we should change our methods to meet that. So that's my introduction, who I am. This is all new to me too, so I'm just going to go look at this and see what it says. These are, we already talked about the twice-a-year meetings. The 6 different type of standards. The 2 that we look at most are the methods and the guides. And right now we have 2 standard practices going to ballot. The karst characterization, Scott Engel, I've been working with him on that. And we're always looking for volunteers to help out on that. And this is basically, a type 1 investigation, which you already talked about. And then, again, Robert Denton's talk is type 2, so it's the part of the Department of Redundancy Department. And but here's some new ones now. This dye tracing. We need somebody to spearhead this, to take charge, find volunteers to help out, and put something together as a really important aspect of karst. And the same thing with non-dye. I'm not familiar with that, but apparently there is somebody who is very familiar with it, Garth Davies. I don't know who he is. I don't know, is he here? No. So hopefully we didn't just volunteer him. Hopefully he volunteered. But he needs help in putting together a non-dye tracing effort. That would be a standard. And then remediation of sinkholes. The current method I've seen is pour grout in it, pour sand, pour dirt in it. And maybe that's not the best way to do things. So we need a task force leader to spearhead the different mechanisms involved in stabilizing a karst feature that's impacting roads, buildings, whatnot. That would be you, Connie. So maybe Connie, she's an engineer, so she would know how to do all this stuff. In our part of the world, we have what's called LCM, liquefied cementitious matter. It's the waste product of coal burning in power plants, and they pour it into the mines when there's an issue, and it's hardened. It doesn't have any wearing ability, but it's mass, so you can pour it down. It's cheap. I'm not sure that's a good thing, because who knows what's in that waste product from the burning of coal. And then cave ecology, we had a volunteer, Brian Cohen. I don't know if he's here. He is there. There he is in the back. He needs volunteers to help him with cave ecology. And I did not think that salamander was ugly, by the way. I thought it was actually pretty cool. I've always wanted salamanders when I was a kid as, kind of pets, I guess. So that's pretty cool. And I'm glad you're... This is a road cut in Pennsylvania. Kind of interesting, when they dug that road cut, they found that cave. So pretty interesting. So monitoring parameters. This is something that George had added to my list. Recharge and pumping with respect to sinkhole development. There is no leader appointed right now, so we need somebody who's really interested in this subject matter to come forward and help develop this task group. Same thing with the stormwater monitoring and management. I've done a ton of work in State College, where they happen to have this small university called Penn State. And I actually submitted a paper to this August body a couple of years ago. They take 50 square miles of Penn State and drain it into a sinkhole under a stadium, not the big stadium, the old stadium. And every few years we have to go out there and redefine the size of this void that keeps opening up and dropping the the whole seating system. It's really kind of cool to see what the engineers do with this. They keep it open, they do not close it, but they have to rebuild the whole stand to support. And I don't know if it's now a high school stadium, but the college does practice there during the summer, as I understand it. And so stormwater management, especially for cities that decide the best way to get rid of their stormwater is through an opening in the ground. We don't have a leader for that, unfortunately. And so if anybody's interested in that, that is, I think, a pretty interesting topic. And then I threw this one in. I'm interested in pseudokarst. I see it everywhere, especially in western Pennsylvania, because we have mine voids. If you go north, you have glacial issues where you might have an ice chunk in the ground. It's gone. Now it's bridged over, but it's still unstable. And so basically, I just said, doing a classification standard where you identify the different types of pseudokarst features, lava tubes, things like that. And that's something that interests me. And then ultimately developing a phase one on how to deal with this particular issue. Didn't I show this already? This slide. It's one of my favorite. This is in East Central Texas. So there are other tasks that we can do for standards and for classification. But right now, I think these are the most important ones, since there's only, 30 of us here? So you can't do everything all at once, but we'd really like to get volunteers involved in some of these different tasks and pull together a group, working with Scott and whatnot on phase ones. It's been really enlightening. I really enjoyed it. And I guess, is there any questions?
All right. Any questions for our panel?
You use the term stormwater. Isn't there already a standard? I know we are talking about karst, but stormwater is a general term. Maybe some engineering folks they did a standard.
I don't know if there's, I'm sure there is a stormwater standard, but I think that's more, engineering stormwater across roads and things like that. But this is specifically addressing the use of a cave to get rid of, 50 square miles of Penn State College is pumped into this one void in the Memorial Stadium. So I think these need to be addressed. So, but
Okay.
I do believe there is a standard on stormwater.
There is.
Yeah.
Can you hear me? I can project my voice pretty well.
Yes,
Still need to pass the microphone around,
All
please,
right.
so we can get it online. Thank you.
There is, but what happens is and I mentioned this in the short course I taught on Tuesday, that in karst terrains, they tend, when they're undeveloped, when it's raw land, they tend to absorb more water than non-karst terrains. And as the rainfall amount increases, they become more and more like the non-karst terrains. But you have to use a different curve for your stormwater calculations in karst than you would for a standard area. And as you increase the amount of impervious, the difference gets even more. So stormwater management in karst has its nuances, and it is slightly different, and actually not even slightly different, it's considerably different than it would be for non-karst areas. And the current standard is written for just generalized non-karst areas. So we'd probably have to have a standard that's key to karst.
But probably have to specify, this is karst stormwater or something.
Exactly.
To separate it, because otherwise, I bet it's a database. You type in storm, and the stormwater is showing up.
Yeah. Yep.
Dore. Thank you.
Exactly.
This isn't a question, it's more of a comment, but I just want to say how really important this is. We do a lot of work here in the Tampa Bay area, and I'm just going to give you a couple of examples why it's important. There's counties to the north that have geological hazard ordinances, which put the onus on the geotechnical engineering companies to go through and do a karst hazard assessment. But there's absolutely no definition in terms of what's adequate. So I've had instances, and one of the things you have to assess is the location or the planned areas for stormwater retention ponds. So I've been contacted by geotechnical companies looking for a geophysical investigation, and I'll just use radar as an example. It works real well here. And we've got a pretty good idea of what kind of grid spacing would be appropriate to identify the type of karst features that would be in that particular area of the county. And so we'll go through and give a price to that geotechnical contractor, which he'll put into his bid. And then the next day I'll get another call, and someone will say, well, I need to have a karst assessment done. And I said, well, we'd recommend radar. And this is the kind of grid spacing we'd recommend. And he said, no. I just need you to run one line down the middle of this pond because I'm just going to go through and check off a box. So that puts the consultant, our company, in a kind of a precarious position where we're not the sinkhole police. You know, we're serving our clients, and they're providing a price on the one that's going to do the one transect. They're probably going to win the project. But because there's absolutely no standardization, they can get away with that. And I've called the county. The county's asking for guidance, and the response that I get is, well, we're just going to use your professional judgment, which is a hole you can drive a truck through. So having these kind of standards developed will really help a lot in terms of the consulting industry, specifically from the geophysical standpoint, helping our clients meet their requirements for proper assessment. So I'm really glad, and I'm going to volunteer to help on one of these subcommittees. I think this is a great effort.
Yeah, a corollary to that, of what you're just describing, and this was one of the impetuses for me to actually work on some kind of a standard for Virginia. In Virginia, most of our counties that have every county west of the Blue Ridge, basically, is about a quarter of the counties in Virginia are either underlain completely or partially by karst terrain, or karst terrain underlain by karst-forming bedrock. The problem is, in these rural counties, many of them don't have any engineering staff at all. They bring an engineer in. He's an on-call engineer, and he's usually a civil and not trained at all, even in geotechnical engineering. And so this is the problem, is that they you know, if you have an issue come up, the on-call engineer isn't even qualified to make a judgment or make any kind of a decision because he's never been trained in that. And so this is, and I've seen this all over the country, you know, not just in Virginia. And it's the idea that, you know, many karst areas are very rural, and in rural counties they don't have the money and to have a full-time engineering staff. It's really an issue, you know. So
during my presentation, I talked about the potential as being huge for standards that can be developed in karst. And Mike, what you're talking about is an example. There's a tendency, okay, we'll develop geophysical standards. Well, no, you know, there's one standard that should be developed for ground penetrating radar, another for electrical resistivity, another for electromag, another for magnetotellurics, another for seismic, microsize, you know, microgravity, and so forth. You know, because each of these technologies are different. Each of them have their own pros and cons, their own challenges, and so there's a lot of work to do. There's a huge amount of work, and so we want to make sure that these standards are also broad-based enough so that it doesn't work, you know, in my backyard, but it's not effective in someone else's. But those are some things we're looking at. And again, thank you for offering to help out, because it's a huge amount of work, and it's important. I mean, you know, not too far from here is Sefner, where, you know, poor man died in his home when the sinkhole opened up, and that's not a unique situation, sadly. You know, this stuff is important. You know, people have died from groundwater contamination in karst. This stuff is important. So, anyway.
Just a little fun fact about the Sefner. That was a patio slab. His bedroom was built over a patio slab, so that wasn't proper foundation. So we're there, but that does speak to building codes in karst landscapes. Really have to step it up to have redundancies designed in, so that when stuff, you know, backyard patio, unreinforced, no footing, backyard patio aside, you know, that this will pave the way to that kind of, you know, building code response. So.
We'll make this easy. Very intriguing. I'm curious, you know, Jeannie, you mentioned, you kind of gave us a great overview of the big picture process. And then we learned about the various different components that are being thought of now some with leaders. Obviously, those I would imagine are further along in the process, as opposed to others where there's we're looking for volunteers to lead and also to help. I was just curious, what I didn't get is a sense of, for assuming some of these are further developed, further along, kind of where are they in the process? What's the next step to actually getting a standard, finalized?
Right. It was a little lost in all of this, but so Bob Denton's task group has a. You want to talk?
No, I think he's about raising it close to.
Oh, sorry. Bob Denton's task group has a standard that's at the main committee balloting level, so we are very close on that standard. And he was outlining some of what's in that standard. So that's the preliminary karst one. In addition, Scott, right? Scott has one that's in the subcommittee level. So we have two standards right now in balloting. One is pretty close to going on the books. And some of the other task groups are probably, or some of the other, task groups of the subcommittee are still in the development phase. So they haven't reached that point where they're going to the subcommittee level quite yet. But it takes a while because quite a few of these members are pretty new to the process. So it takes a long time to get to the point where we get standards on the books. And we could use some volunteers to help. But ASTM is a little bit of a learning process. So does that answer your question?
Yeah, it does. I just was curious as to the progress of the different subcommittees and where they're.
Yeah, so we're really close on one and pretty good on another one.
I can address the phase 1 a little bit. Here, wait. People can hear me, right? No, it's not just people here, but this is being live streamed, and so the folks need to be able to hear you. All right. We took the existing phase 1 apart and then looked at it and put it back together to address, karst for a phase 1 evaluation for karst. And these standards really aren't that complex. They're templates everywhere in the whole ASTM thing, and you just have to look at what other people have done, disassemble it, and then put it back together, addressing the issues with you. Right now, I think ours is being held up a little bit by somebody who's objecting to a certain terminology, and that's good that we have to work through that. Once we get that all straightened out, then we can send it over and get it voted and whatnot. So but it wasn't that hard. I couldn't believe how easy it was. We just literally took the existing phase 1, took it all apart and put it back together. And I think, and I don't know what the existing stormwater one looks like, but I can assume that person will look at the existing stormwater regulation or a standard and then take it all apart and then put it back together, addressing, karst features.
Great. Yeah. Thank you. That answers my question.
This might be kind of an ancillary question. Obviously we want to develop these standards and get them put in karst management plans and promulgate it maybe on state levels or county levels. Bob, maybe you can answer this. Did you have any pushback when Virginia was developing their standards, from any groups or anything like that wanting to have these? I would assume, realtors or something of the sort.
Well, when the Cave Board promulgated the standard for our standard practice for surveys, we didn't necessarily get any pushback. Now it's voluntary. I mean, it's a guidance. So my old saying is, Virginia we love creating guidances, and then West Virginia steals them and makes them into laws. But what we're working on right now is actually a major revision of the stormwater manual for Virginia and the erosion and sediment control guidance manual for Virginia. And there we are, we're seeing some resistance from certain stakeholder groups and stuff like that, because they're going to have to do things now, especially when it comes to karst with stormwater management, that Unfortunately, stormwater management in many places has always been pipe to pond. That's just the way we do it, pipe to pond, you know. And the problem is, in karst terrain, you know, if you're doing the standard, let's say, you know, an extended detention, unlined standard detention pond, in karst, more often than not, the thing is going to fail. It's going to develop a sinkhole, and then the whole contents of the pond will be disgorged into the subsurface, including all the contaminated sediment that's in it. And this has happened over and over again. And so, but people don't want to spend the money to do the investigation, to do to have to install the liner, to, you know, do all these things. And so, yeah, there's been some resistance, but, you know, hopefully we're going to get this new guidance manual completed sometime probably early next year. Resistance or not. So, but yeah. And one thing I wanted to remind everyone, the Virginia guidance document is available online. You just have to go to Google Virginia Cave Board and scroll down, and you'll see a little link there for the PDF. And that's that was actually acted as a template for the practice that our task group wrote for the new standard practice. And again, keep in mind the one practice that we've got that's in voting with the overall D18 committee right now. It's just the preliminary assessment. It's not the detailed assessment. My vision has been that just like the phase 1 environmental site assessment process, you have a phase 1 and a phase 2. The phase 1 is a standard practice. The phase 2 is a guidance. The guidance gives you more of a laundry list of things you can do. All right. And my vision, my dream, is that in fact we will then move on to develop a guidance for the detailed site investigation, which will be very similar, structured very similar to the phase 2 environmental site assessment guidance.
So not really a question, just a statement. If anyone here does have expertise or interest in the ecology side of things, please come talk to me. Right now I am the subcommittee and I would love to have some help. And you know, as Peter was mentioning, there are other documents out there that we can build upon. So this isn't going to be just building everything from scratch. And so I think this process can be relatively painless, but you know, we need more people, more minds really applied to this. And if another subcommittee interests you, please consider volunteering. I just started volunteering in January, and the process was very simple to become enrolled and to join the committee. And you do get to meet a lot of the top performers in your field. So if you're thinking about it, please do it.
While the microphone is being passed, I'll maybe restate the obvious, but there's a lot of stuff already out there, a lot of publications out there, and they just need consolidating, updating, tweaking, and massaging into the ASTM format. One thing to be aware of that just was recently published by the International Union of Speleology and the IUCN, the International Union for the Conservation of Nature, is the guidelines for cave and karst protection. It's on the UIS website. Just Google guidelines for cave and karst protection. Greatly expanded, but even that is a very broad document, and you know, a lot of ASTM standards could actually be worked out in more detail on that topic. Calvin?
I have a problem which I would like to ask advice on.
Is this on?
I said, I have a problem that I would like to ask the committee's advice on. I simply have no idea how to handle it. The largest blind valley that we're aware of in Minnesota that we have traced to big springs that are 11 miles away has been disappeared from a USGS topo map. It's on the paper map, the 1960s paper map that we use. It's got, it's well indicated. They show a stream flowing in and ending there. We've traced that stream. There's 2 closed contours around it. It's a better part of a section. It's a big feature. And if you go online and look at the new online versions of it, that feature is simply not there. They have added a straight channel that drains it. They run the river all the way through it and continues. The dye trace shows that the water, it's about a 15 square mile basin that drains into that blind valley. And our dye tracing shows it comes up on the upper Iowa River. In other words, it feeds a completely different drainage from what they're saying. And I was just flabbergasted when I went online and pulled it up, and they put something that's just not there.
Cal, I'm glad you brought that up, because we've been doing karst surveys, basically preliminary surveys for new solar fields all over the country. And one thing that we've been noticing when we go, because I like to look at both the most recent 7.5 minute topo and then the historical ones. And what I've been noticing is that now on the new ones, you don't ever see the inward hatched closed depressions. They're vanishing, and I don't know what's going on. It's really strange, and yet
somebody is deliberately taking them off the map.
I know, and I don't get it. I don't know why this is happening. It's the strange, and we've been noticing this. It's like it's all the maps that have been revised in the 2000s. The inward hatched closed depression indicators, they're gone. They're just gone.
They're just gone.
And so we have to look back. I end up looking at topo sheets from the 1980s and 1970s because they're still there on those maps. Yep. But it's very strange, and I don't get it. Maybe we need to ask that doctor what's going on. I don't know. Somebody here from USGS.
I have heard a rumor that this is because the USGS is trying to show that all water runs to the ocean. And they don't know how to deal with blind valleys and things like that. They don't know where the water goes, and they want it to go somewhere, and so they just change it.
That's a good point, because that's what other thing we've noticed. You know how they used to show, they would show a perennial section of a stream, and then it would go dashed, where it's an intermittent or ephemeral section. And now all of a sudden those are starting to disappear too, is what I'm noticing. Or they're making them uniform. It's either all dashed or all solid. And it's it's strange. It's very strange.
I have a little bit of knowledge on this. I don't have the answer to Calvin's question, but I believe the reason that the hatchers have disappeared is because it's a limitation of the way they're creating and distributing the digital files now from the national map, that rendering a line that has those inward hatchers doesn't appear to be, built into that capability for the vector-based distribution. But a similar problem is that even the scanned older maps from the national map are at a pretty low resolution when you try to zoom in and use them on a local, for a local project, and it's really unfortunate. Dan, Doctor, would be a good one to talk about this.
Our what we've done anymore, I only look at the topo sheets just to say that yes, we looked at the topo sheet when we're in our report, but we get our actual terrain data anymore. What we're doing is we get the LiDAR, we use the DEM, we then create 1 or 2 foot contour maps from that using GIS. Yeah, but it's and very often we will comment in the report on errors in the Dan and I talk all the time. I constantly get in touch with Dan when we found out that the Lockport, the USGS karst map, the national karst map, the Lockport limestone up in northern New York, it runs all the way underneath the Great Lake there. It's not on the karst map. It's not indicated as a karst unit. Dad looked. He said, "Oh no." So that's going to be fixed on the next iteration of the map.
That's a real good point. I mean, we're straying away a little bit from from the ASTM topic, but I recently had someone complain to me vigorously about how terrible the national karst map was because it's missing this one guy's favorite karst area.
And I said, the very detailed work that Dan and Dave Weary did for that, and more importantly, they want feedback. They want to know what they missed. So if you do have anything, again, this is straying away from ASTM, but if you do have any corrections, improvements for the ASTM map, or I'm sorry, for the for the U.S. National Karst map, talk to Dan. He's here. Let him know. He really will appreciate that. So, yeah, I've heard you have some connection with Dan as his former advisor. Any other questions, comments, thoughts, suggestions?